So in this tutorial we are going to talk about complex numbers. So we solve a lot of questions under complex numbers. So I have the question here, the first question, which is saying perform the indicated operations, simplify and write the results in the form of x plus iy. Okay, so any expression which you are going to have which is in the form of x plus iy, sometimes it can be yi, is what we call a complex number. So a complex number has got two parts. Okay, the part which doesn't have I is what we call the real part. The part which has got an I is what we call the imaginary part. Okay, so if I've got sometimes they can use a and b, they can say a plus bi, sometimes it can be ib, that is okay. So you can clearly see that a doesn't have I, that is the real part. B has got I, that is an imaginary part. Okay, so that is complex numbers. So complex numbers, one thing you have to understand is that when we're talking about complex numbers, it's a number which has got both real part and imaginary part. For example, I can give you the square root of maybe -4. Initially we know that this is undefined, but if we go to complex numbers, then we'll say this is 2i. What does it mean? We're just imagining. It doesn't exist, but we're just imagining to say it is 2i. Now that I chose us to say it is a complex number, we are just imagining, okay, it's 2i. But we'll talk more about this I. Okay, so before we solve this, I want us to talk more about I. So if you have got the square root of 1, initially this is I, so I shows us that this is just imaginary. Okay, so if I can square both sides, I can clearly see that I'll have I squared to be equal to what? To be equal to 1. -1 in this case, because inside we have got -1. So I'll end there. Where there is I squared, we have to replace it with -1. But we'll talk more about I later. Okay, now let's start. So the first question is addition. We have to add this and that. The best thing to do is just to open the brackets, but if you can solve this, you can just pause the video and work it out, then continue to see what we're going to do. So we have 3. Okay, we have 3 minus 4i, then plus -5 plus 7i. I can just open the brackets, or I can do times. This is positive times what is inside there, so I'll have 3 plus 4i minus 5 plus 7i. So we add the real part and the real part, the imaginary and the imaginary. So in this case, 3 minus 5 is -2. Then -4 plus 7 is 3i. So we are trying to write this in a form of x plus iy. So in this case, x is -2, iy is 3i. As simple as that. So that's the answer for the first part. Let's go to the second part, which is 4 plus 2i in the brackets minus -1 -3yi. First, I will rewrite this. I will just open the brackets. So I'll say negative times -1, here is going to be +1. Even here is going to be plus 3i. Because of this negative in between, at this point I can now say the real part and then the imaginary and the imaginary. So the real part is 4. 4 plus 1 is what? Is 5. okay, plus 2 plus that one is 5i. So that is my answer. We go to the next one. We'll see that it is 2i. Now this is multiplication now. 3 then 2 divided by 5, like that. Now there is I here. So you do one by one, this times that, again that times that. If you don't want to make any mistake, I would advise you to use this, because this is the same as 2 open brackets 3 minus 2 over 5i, like that. Then again you say plus I, then open brackets 3 minus 2 over 5i, like that. So have 2 times 2 is 6. 2 times that one will get 4. 2 times 2 is 4, to 4 over 5i, then plus I times 3, 3i. Next I times what I have there is going to be 2 over 5i squared. 2 over 5i squared. Now I can simplify this. I know that I have the imaginary part, or what we can do is 6 minus 4 over 5i plus 3i minus 2 over 5 I squared. We said we have to replace where there's I squared with neg 1, meaning negative 1 negative, and that negative is going to give us now positive. So we'll end up having 6 minus 4 over 5i plus 3i. Then now this is going to be plus because of this negative and that negative, so it will be 2 over 5, like that. Now the next thing I have to do is 6 and 2 over 5, they have to be added. Negative 4 over 5i plus 3i have to be added as well. So I'll start with 6 plus 2 over 5. Okay, so the common denominator is 5. 1 into 5 is 5. 5 times 3, that is 30. So I'll put 30 here, plus 5 into 5, 1. 1 times 2 is 2. So I'll have 32 over 5, like that. So now I have 32 over 5. I need also to add the imaginary part, which is negative 4 plus divided by 5i plus 3i. Here I'll put 1. The common denominator is 5. So 5 into 5 is 1. 1 times negative 4, negative 4. Plus now this is I. Because of that I, we should have 1 into 5 is 5. 5 times 3 I is going to give us what? It's going to give us 15 I. So negative 4i plus 15, that will be 11. So 11i over 5, that's what I'm going to have here, plus 11i over 5. So the best way to rewrite this is 32 divided by 5 plus 11 over 5, then you put I here. So this is my answer. Or in case you have not seen the answer, that's the answer. 32 over 5 plus 11 over 5i. Now we go to the next one, which is open brackets. We have 3 over 4 plus 5i, again open brackets, and then so this is addition, this is subtraction, and these two, they are multiplication. So I'll have 3 over 4 again, yes, 3 over 4 minus 5i again. So we do times. Now, so here what we're going to have is, I'm going to have 3 over 4 open brackets 3 over 4 minus 5i, then plus 5i open brackets 3 over 4 minus 5i, like that. Then 3 over 4 times 3 over 4, this is going to give us 3 over 4 times 3 over 4, this is going to give us it's going to give us 9 over 16. So I have 9 over 16, okay, then minus 3 times 5 is 15 over 4i, plus 5 times 3 is going to be 15 over 4i, then 5 times negative 5 is negative 25. Now there's 25i squared, like that. Now we can clearly see that these two things can be cancelled out. It's going to give us 0. Then I'll end up having 9 over 16 minus 25. I squared is neg 1, so I've replaced that one with neg 1. So I'll have 9 over 16 plus, now because of negative 1 and negative 25. Here there's 1, so I'll say the common denominator is 16. 16 into 16, 1 times 9 is 9. 1 into 16 is 16, then 16 times 25. Okay? 16 times 25 is 400. So 9 times 400, or 9 plus 400, sorry, which is 409, divided by 16. Because of this 9, there is no number which can go into 16 and 409, so I'll end there. Now what you should know is that if you have got a number just 2, we still have the real part and the imaginary part. So in this case it's the same as 0i. So this is the real part and this is the imaginary part. So like in this case they are saying we should write our answer in x plus iy. So what does it mean? Our x is this which we have, which doesn't have I. The one which has got I, in this case this can be written as 409 times divided by 16 plus 0i. So 0i is the imaginary part, 409 over 16 is the real part. Okay, because we are supposed to write this in form of x plus iy, so it's supposed to be 409 over 16 plus 0i, as simple as that. Now the best thing, again, you can also use another method to solve like this question, because one thing we have to understand here is that we have the conjugate of each other. In a case where you don't understand the conjugate, I'll explain. If I have 2 plus 4i, the conjugate of this is 2 minus 4i. The one having I, you need to, if you have got negative, you're going to put positive. If you've got positive, you put minus. Okay, now one thing we have to understand here is this is the conjugate of each other, this is the conjugate of that, again that is the conjugate of that. So I'm going to get to say this was the original one, then the conjugate is that. But at the same time you can think of this, then the conjugate of itself is that one. Now you just square the one having negative. Okay, in this case I'll check, this is the part 1, part 2, which one has got negative? Okay, it's the second part, so I'm going to square that part. What do I mean? 3 over 4, if I square it, minus 5i, then I square it, I'll end up having the same answer. So if you're multiplying the number by its conjugate, if you just square the one having negative, that is the answer. So in this case I'll say 3 times 3 is 9, 4 times 4 is 16, minus 5 is going to be 25i squared. I squared is going to be replaced with what? It's going to be replaced with neg 1. Again, I'll end up having this 25, which is the same as 409 divided by what? Divided by 16. You see, so it's the same thing. Now we move to the second part. So now the two questions we're from doing, this one and that one, they are from multiplication. This is addition, this is subtraction. The next one is division. Now division, for you to work out that one, we use what we call the conjugate. So let me introduce the concept of conjugate. Okay, How do you work out with the conjugate? If there is division, we multiply by its conjugate, okay, to remove the I on the denominator. That's the whole purpose. So if you have got 2 plus 3i, the conjugate of this is 2 minus 3i. What if you have, I give you a different one, 2i minus 3? The conjugate of this can be written as, because we know that complex number is in the form of x plus iy. So this can be related to say negative 3 plus 2i, like that. And then the best thing you need to do here is you can say negative 3 minus 2i, that is the conjugate. So you change the sign where the part which has got what, which has I. Okay, so let's go ahead now and solve this one, the division which we have here. So 1 plus 3i divided by 3 plus I. So I'll say this times the conjugate of the denominator, so it will be 3 minus I divided by 3 minus I, like that. Then I'll start now. 1 times 3, which is going to give us what? 1 times 3 is going to give me 3. Then 1 times negative I is negative I. Then 3 times 3, 3i times 3 is going to give me 9i. Then 3i times negative I is negative 3i squared. Then divide it by, so this one you can say this times that, but again, for this one, what I'm going to do to make things simple and easy for us, I'm going to square the one having negative. What does it mean? It's the same thing, saying this times that, again that times that. It's the same thing. So, but you just square the one having negative. I square this, I put them in brackets, minus I also put it in brackets. You square it. So I'll end up having 3 I, and that one I'll have plus 8i, then minus 3, then I squared will replace with negative 1. We divide this by, this will be 9 minus this will be negative 1 because of I squared. So I'll end up having, this is going to be 3, because of this negative, this is going to be plus 3, then plus 8i divided by what? Divided by 9 and negative, this is going to be plus, so it's going to be 10. Now we can clearly see that this is going to give us 3 plus 3 is 9. 3 plus 3 is 6. So I have 6 plus 8i divided by 10. But remember, we are trying to write this in form of x plus iy. So I'll say this is the same as 6 over 10 plus 8 over 10i, like that. Then I'll start now dividing. 2 into 6 is 3. 2 into 10 is 5. Plus 2 into 4, because I know that 2 is the one which can go into 4 or into 8 and 10. So I'll say 2 into 8 is 4. 2 into 10 is 5. Then I put I. So this is my final answer for part 5. Now I go to the next part, but the next part, I believe you can do the same thing we are from doing and come up with the answer. So what you can do is you can solve this and send me the answer in the description. If you have my number, you can send direct to my inbox. Okay, so for those who are not registered, if you want to be registered with Transcended Institute, you can just get in touch with us or follow the link in the description, and then you'll be able to be part of the team. Okay, so I'll not solve part 6 because it's the same procedure. Just follow the same thing and solve it. Okay, and then send the answer in the description or in the comment section. If you have got a chance, you can just type the answer in the comment section and then I'll check it out. So let me go direct to this one, which is 3 minus I then I've got 2 plus 3i divided by 1 plus I, like that. So the best thing is to simplify the top part. The top part I know that is multiplication. Okay, so let me just work out with the top part there, which is 2. It's the same as 2 open brackets 2 plus 3i, then minus I open brackets 2 plus 3i, like that. 2 times 2 is 4, 2 times 3 is 6, but there is I, minus or first I'll say negative I times 2, it will be negative 2i. Negative I times that one, it will be 3i squared. So this will be 4. These two can be added, which is going to give us 4 plus 4i minus 3, then there's negative 1. So this and that is going to be plus because of this negative, so it will be 4 plus 3, which is 7. 7 plus 4i. So I'll replace now the top part with what I'll say is 7 plus 4i divided by 1 plus I, like that. Okay, let me do it. Maybe I've made a mistake. I'm saying 2 times 2 is 4, 2 times 6 is 6i, then negative I times 2 is negative 2i, negative I times 3i, negative 3i squared. So these two, 6 minus 2 is 4, which I have there, the 4 here, and then there is going to be 7. Yes, it's just okay. Now at this point I can conjugate. What I'm going to do is I'll say I minus 1 minus I divided by what? Here now is going to be, this is going to be again 1 minus I. So I'll start 7 times 1 is 7. 7 times negative I is negative 7i. 4 times I is plus 4i. Then 4i times negative I is negative 4i squared. The down part, if you want, you can do 1 by 1, or you can just square the one having negative, which in this case is this one. So 1 squared, put them in the brackets, minus, don't square the negative, like that. So it will be I'll have 7, then these two can be added. Negative 7i plus 4 is negative 3i. This is going to be negative 4 times this negative, which is going to give us plus. The down part is going to be 1 minus, because of that negative is going to be like this, negative 1, because I squared is negative 1. So we'll go there and say this is going to be 7 plus 4, because of this negative here and that negative will plus, minus 3i. Divide this by, down part will have plus, so it will be 1 plus 1 is 2. The next thing what I'm going to have is 7 plus 4, which is 11, minus 3i. You divide this by 2. I can write this as same as 11 divided by 2 minus 3 over 2i. So this is going to be my final answer in this case. Okay, so you can use the same procedure which we're just from doing to answer part 8. Okay, so part 8 is going to be 1 plus I, and then I also have 1 minus 2i. I divide this by 2 plus I. Okay, then 4 minus 2i. So now what I'm going to do here is I'm going to simplify the top part and the bottom part as well, and then we conjugate it. So I'm going to say 1 times 1 is 1, then 1 times 2i is 2i, then next I'll go to I. So I times 1, I'm going to get plus I, then I times negative 2i is 2i squared, so it's negative 2i squared. So remember, where there is I squared, we replace it with neg 1. So I'll go to the bottom part now. I'll say 2 times 4 is going to be 8, then 2 times negative 3i is going to be 6i, then I times 4 is going to be plus 4i, then I times negative 3i is going to be, now bottom part here I've got 2. Oh no, we are solving this one, so it's I times negative 3i, which is the same as what? Negative 3i squared. Okay, so now I'm going to simplify further to say 1, then the negative 2i plus I is negative I. Okay, then negative 2, here there is I squared, so I'll put it negative 1, then I'll divide it by 8. I've got 8, and then I'll have negative 6i plus 4, which is negative 2i. And then I'm going to say I squared, I'm going to replace that part with negative I, like that. Okay, so the next thing what I'm going to do is, I know that this is going to be plus now, so I'll have 1 plus 2, which is going to be 3, minus I. Then the bottom part, I know that it's going to be 8 plus 3, which is going to be 11, minus 2i. So now I can conjugate the denominator. So I'll just create space on top here, and then I'll have 3 minus I, then 11 minus 2i. Then the next thing, I'm going just to get the conjugate of the denominator. So I'll have 11 plus 2i divided by 11 plus 2i. Okay, so the top part I'm going to do one by one, but the bottom part I'm doing times the conjugate, so I'm going to get the one which is having negative, then I square it. So I'm going to say 3 times 11 is 33, then 3 times 2i is plus 6i. Okay, then negative I times 11, negative 11i, negative I times 2i is plus 2, or is negative because of the negative which I has, so it will be negative 2i squared, like that. Then now here, instead of me wasting time doing one by one, I'll square the one having negative. In that case is 11, so I'll say 11 I square it, negative 2i I also square it, so I'll end up having 33, then 6i minus 11, that should be negative what? That is negative negative 5. So I'll have negative 5 I, then this is negative 2, but is squared, I is squared, so I'll put it, I'll replace I squared with negative 1. The bottom part, 11 times 11 is 121. Then here I have got 4 I squared. I squared can be replaced with so I'll have this part is same as plus, so I'll have 33 plus 2, which is 35, then minus 5i. I divide this by the bottom part here is 121 minus 4, then again I'll put I. So from there now I'm going to say 35 minus 5i. I divide this by, so this is going to be now plus, it's going to be 121 plus 4, which is 125, so I'll have 125 here. So we want to write this in form of x plus iy. So x plus iy, then I'm going to isolate this. I'll say it is 35 over 125 minus 5 over 125i. 5 can go into 35. Okay, so 35 divided by 5 is 7. Then 125 divided by 5, that is 25. Okay, minus again here 5 into 5 is 1, 5 into 125 is 25, so I have got I. Now I can clearly see that this part is the real part, then the next one is the imaginary part. In this case 7 over 25 is x, then negative 1 over 25i is iy. Okay, so for the next question you can use the same procedure, although this one is simple. You can also use the same procedure, you work it out, you come up with the same answer.
Alright, so if you're looking to full solutions to the tutorials that you have, basically the calculus one, for example, you see that all the questions have been answered and are available on our site, all the way up to question 11. And of course, the same applies to the other part, the other tutorial sheet, which is on complex numbers. You notice that they are also solved here. You can see the questions all the way up to question 9. So you can actually access all these by just registering on our site. So in addition to that, you can also learn all the other topics that you need to prepare for in your assessments. Okay, so you need to learn limits, videos are here, differential calculus, and also the complex numbers. So all you just have to do is just go to learn.transcendedinstitute.net, and of course every information is in the description on how to go about the registration process. So the same applies to the other courses: chemistry, physics, and biology. The theory solutions are available on our site at a very affordable fee of only 80 kwacha per course. All the best as you rate assessments.
Okay, so we're now on question 9, which is 5 minus 4 in the brackets, which is 4i, minus 3 plus 7i in the brackets, then divided by 4 plus 2i in the brackets, plus 2 minus 3i in the brackets. So how can we work out this one? So this is also direct. It's just a matter of us opening the brackets. So in that case, I'll say 5 minus 4i, then I'll open the brackets, minus 3 minus 7i. Then down part, if I also open the brackets, it's going to be 4 plus 2i plus 3 minus 3i, like that. So this, we are solving this one here, which is 9. Now I've just opened the brackets there. So 5 minus 3 is 2. Then negative 4 minus 7 is negative 11i. I divide this by 4 plus 3 is 7. Then 3 minus 2 is negative 1, which is just negative I. Now we get the conjugate of this. So this is going to be times 7 plus I, even here 7 plus I. So I'll start. 2 times 7 is 14. Then 2 times I is plus 2I. Negative 11 times 7 is negative 77I. Negative 11I times I is negative 11I squared. The down part, just square the one having negative. If you're multiplying this by its conjugate, you square the one having negative. So in this case, I'll square that. Okay, so what are we going to have? On top here, we are going to have 14. Then 2 minus 77, which is negative 75. Then I'll have minus. Now this is I squared, so it's the same as negative 11 times negative 1, which is plus 11. I divide this by 7 squared is 49, minus, here I've got this negative 1. I squared is negative 1. So I'll continue from here. I'll have 14 plus 11, which is 25. Then minus 75i divided by, this is going to be 50. Okay, so to make things simple, I can now divide both sides by a number which goes into 25, 75 and 50. So this is the same as 25 divided by 50 minus 75 divided by 50i, like that. Then I'll say 25 into 25 is 1, 25 into 50 is 2, then 25 into 75, this should be 3. Okay, yeah, this is 3. Then 25 into 50 is 2. So this is my final answer in this case. So we go to part 10. which is 4 plus 5i, everything in the brackets, then plus 2i squared. Divide this by 2 plus I, like that. So one thing we need to know is that I'll just write this the way it is in the brackets. So I'll remove the brackets. Plus, this is going to be 2. Where there is negative I, replace it. Where there is I squared, replace it with negative 1. I'll divide this by, this one now is the same as 2 times 2 is 4. 4 times 2 times I is 2i. Then I times 2 is 2i. I times I is I squared, like that. So this will be now 4 minus 2. This one will be minus because of that negative 1 there. So it will be 4 minus 2, which is 2, plus 5i. Down part here we'll have 4 plus 4i, then minus what? Minus 1, like that. So we'll come here and say this is 2 plus 5i. The down part will be 4 minus that one will be 3. 4 minus 1 is 3, plus 4i. Now I can get the conjugate of the denominator. So it will be 3 minus 4i, 3 minus 4i, like that. So what are we going to have? We'll have 2 times 3 is 6. 2 times negative 4i is negative 8i. Then 5 times 3 is plus 15i. 5 times negative 4i is negative 20i squared. The down part, when you're multiplying this by its conjugate, square the one having negative. So here I'll say 3 squared minus 4i, then I square this, like that. It's the same. Even if I do this times that, this time that, it's the same thing. So I'll continue from here. I'll say this is going to be 6 negative 8 plus 15. Okay, what is negative 8 plus 15? That is 7. So meaning is positive 7i. Now there, since we have got 2i squared, it's going to be plus 2 because of the negative I squared is negative. Now I divide this by 3 squared is 9. Okay, then minus, I'll have 4 negative, 4 squared is 16. Let's not forget that one. So it will be 16 I squared. I squared is negative 1, like that. So we'll have 6. This is going to give us 8 plus 7i. We divide this by what? We divide this by, it's 9 plus 16. What is 9 plus 16? This is 25. Okay, so my final answer will be 8 divided by 25 plus 7 over 25i. So this is my final answer for part 10. Let's jump to part 11. Although the procedures are the same, so part 11 we have 1 plus I raised to the power 2, 1 minus I raised to the power 3. The best thing here is we expand this, okay, which is going to be 1 times 1 is 1, 1 times I is I times 1 is I times I is I squared, like that. I'll leave this one first, so I'll have 1 plus 2i, then minus 1, because I squared is 1. So 1 and 1 can go. Now I can clearly see that for this part I only have 2i. Let's now expand this. We have 1 times I, again 1 times I, even here 1 minus I, like that. So I'll start with the two ones. 1 times 1 is 1, 1 times I is I, like that. The next thing we're going to have, negative I times 1 is negative I times negative I plus I squared, like that. So let's see what we're going to have. This is going to be 1 minus 2i. This is going to be minus 1. This and this will cancel. I'll remain with negative 2i, like that. So now I have got negative 2i Let me use a different color here now. I have negative 2i times 1 minus I, like that. So say this negative 2i times 1 is going to be negative 2i, then this will be plus 2i squared. So it will be negative 2i minus 2, like that. Now I need to multiply, so it's like I have 2i open brackets negative 2i minus 2, like this. So I multiply. I'll have this times this is going to be neg 4i squared minus 4i, like this. I can now get rid of this part here. So I'll have negative 4, where there's I squared we put it negative 1 minus 4i, like that. So I can clearly see that my answer will be 4 minus 4i. As simple as that. I'm done with that part. I can now jump to 12, part 12, which is 5 plus 6i, then plus 4 minus I, 3 plus 5i, like that, minus 1 over 2 minus I, like that. Okay. So the first thing here, I'm going to work out with this one, which is in between, because these two are multiplying. So I'll say 5 plus 6i, this one I need to put in the brackets. So this one I'll put it in the big brackets, and then I'll say 4 times 3 is 12, 4 times 5 is 20 I, then negative I times 3 is negative 3i, negative I times 5i is negative 5i squared, like that. This one remains the same. So 5 plus 6i, I keep on bringing this, plus. Now this one we clearly know that this is going to be plus 5 now because of that I squared. So it's going to be 5 it's going to be 12 plus 5. Okay, so 12 plus 5 is 17. So it will be 17, then 20 minus 3. 20 minus 3 is 17 as well. So it will be plus 17i, like that. Then here I've got minus 1 over 2 minus I, like that. Now I can open the brackets for the first part here. So it will be 5 plus 6i plus 17 plus 17i minus 1 over 2 minus I, like that. So the best thing which we can do here is I'm going to say 5 plus 17. So what is 17 plus 5? Which is what? 22. Because 17 plus 3 is 20. Now 2 is going to be 22. So you have 22 plus, and then 6 plus 17. Since 5 plus 17 is 22, so this should be 23 now. 23i, then minus 1 over 2 minus what? 2 minus I, like that. The best thing which we can do here is I can find the common denominator if I want. Here there is 1, here there is 1. So what's the common denominator? In this case, the common denominator is 2 minus I. So 1 into 2 minus I is 2 minus I. So I'll have 22, open brackets, 2 minus I, plus again here 23i, then here 2 minus I. Then here I'll have minus 1, like that. So let's see. We'll have 22 times 2 is 44. 22 times I is 22i. Then plus 23 times that is going to be 46i. Then 23i times I, it will be negative 23i squared minus 1. Everything divided by 2 minus I. I'll continue from this part here. So I can clearly see that this will be negative 22 plus 46, that is 24. So I'll have 44, okay, 44 plus 26, 24, sorry, 24i. Then now this is negative, now it is I squared, so it's going to be plus 23, then minus 1. I divide this by 2 minus I, like that. So I'll have 23 minus 1 is 22, so 44 minus 22 is 22 again. So I'll have 22 plus 24i divided by 2 minus I. Now I conjugate the what? I need to multiply by the conjugate of what? The denominator. So I'll have, let me just do it from here. So it will be 2 plus I divided by 2 plus I. So 22 times 2 is 44. I'll write it here. Okay. Then 22 times I is 22I. Then 24i times 2 is 48. 24i times I is 24i squared. I divide this by, I'm multiplying by its conjugate, square the one having negative. Okay, so this will be now, we'll now have 44. Now we know that this is going to be minus. In this case it's going to be minus 24 because of that I squared, so it's going to be 44 minus 24. So what is 44 minus 24? That is 20, because 4 minus 4 is 0, 4 minus 2 is 2, so 20. Then these two we add, 22 plus 48. So what is that? Is 70, because 8 times 8 plus 2 is 10. Then 6 carry 1, so 70. I divide this by, if I square this, will be 4. Then that one will be now negative, negative, it will be this. So I'll have 20 plus 70i divided by 5. This is the same as 20 divided by 5 plus 70 divided by 5i. And this can be simplified to be 5 into 20 is 4. Okay, that is 4. Then 70 divided by 5, that should be 14. So plus 14i. So this is my final answer for part 12. Okay, now let's go to part the last part, which is 2 plus 3i in the brackets. Then again here we have 2 minus I over 1 plus 2i. Now this one we can use, there is one method which we can use, or maybe if you want you can first square each, but the best thing to do here is you work out the one in the brackets first and then later on you square it, which is the same thing. Or if you want you can rewrite this as 2 minus I divided by 1 minus 2i, then you do this. It's the same thing. So what I'm going to do now is I'm going to work out what is in the brackets first, then I'll come and square it. So I have 2 minus I divided by 1 minus 2i times the conjugate, which is 1 plus 2i, then 1 plus 2i. So I'll have 2 times 2 is 2. 2 times 2i is plus 4i. Negative I times I is negative I. Negative I times 2, it will be minus 2i squared, like that. I divide this by I times 1 times is same as I'll just square the one having negative, like the way we've been doing it. So I'll square 1 squared minus 2i. So you square the one having negative always. So I'll have, I know that this is 2 and this is going to be plus 2, so it's going to give us 4. So I'll have 4 plus 3i, because 4i minus I is 3. I'll divide this by 1, then it's going to be minus 4 negative 1. So I'll have 5 down there. So I'm going to have 4 plus 3i divided by, this is going to give us what? It's going to give us 5. It's going to be 1 plus 4, which is 5. So I can write this as like this, and then here replace it by 4 plus 3i divided by 5. Then now you square this. It's the same thing. So now this again, it is the same as 2 plus 3i. Okay, then you have 4 plus 3i, I square it. Then even this one we have to square it, which is going to be 5 squared is 25. So we can simplify first the top part, and then later on we do it with the one which is here. So I'll say 4 times 4 is 16. Then 4 times 3 is 12i. Again, 3i times 3 is 12i. 3 times 3 is 9i squared, which is going to be 9 minus, because this is going to be minus I squared will give us minus. So it will be 16 minus 9, which is 7. So I have 7 plus 24i. So now I have got 2 plus 3i, then 7 plus 24i divided by 25, like that. So we come here and say, I'll continue from this part here. So we are doing now, we are multiplying. So it is 2 times 7 is going to give us 14. Then 2 times 24 is 48 plus 48i. 3 times 7 is 21i. Then 3 times 24, that should be 72 I squared plus 72 I squared. I divide this by, I have now 25 down here. So I have 14. These two can be added, which is 48 plus 21. So what is 48 plus 21? That is 69. So I have 69. Then 72. Yeah, 72 minus what? 72 squared is going to give me negative this. I divide this by 25. So here there is I. Let's not forget. So I have 14 minus 72, which is giving me negative 58. Okay, plus 69i divided by 25. So you can write the final answer as negative 58 divided by 25 plus 69 over 25i. That is my final answer. So that is it for question 1. Okay, we are now on question 2, which is saying find the real RE. It is the real part, which is the real Z. IM is the imaginary Z, given that Z is equal to what we have, and also the part 2 is Z is equal to what we have there. So I'll start with the question part 1. Now this question you can use you can approach it in 2 ways. But the best way, you can first conjugate each denominator and then later on you multiply them, or you can multiply them direct. That is just okay. But the best way to do this is conjugate, work out the first one, which is 1 over 3i. First work out with this one, so I'll say 3 plus I divide it by 3 plus I. And then on top here, since I have got 1, I'll have just what I have there, which is 3 plus I. And then here I'm multiplying by its conjugate. Square the one having negative. As simple as that. So we'll have 3 plus I. Okay. We'll have 3 plus I divided by 3 squared is 9. Then here I'll have I squared is negative 1. So I'll end up having 10. So now the first part here, I have 3 plus I divided by 10, like that. I need to work out the second part and then I multiply them. So I'll say 1 divided by 2 plus 3i. This will be equal to 2 minus 3i divided by 2 minus 3i. So the top part, since I've got 1, the first one we had I, not 1. We had I, so it is not 1. Let me show you here. This is I. So we have made the mistake here. When writing, instead of me putting an I, here, this is supposed to be I on top here and not 1. So if I multiply by its conjugate, which is going to be plus 3 plus I. So it will be I times 3 is 3I. I times I is plus I squared. I divide this by, here I'll multiply, I'll just square the one having negative because I'm multiplying by its conjugate. So it will be 3 minus 1, 3I minus 1, because I squared is 1, then 9 minus negative 9, negative 1. So we'll have initially it's the same as negative 1 plus 3i divided by 10. Okay, so now that part is negative 1 plus 3i divided by 10. Yes. Now we go to the second part, which is 1 over 3 plus 2, or 2 plus 1, 3i. Multiply by its conjugate, 2 minus 3i, 2 minus 3i. So now on top there I'll have the same because I have got 1. There is no need of me wasting time. 1 times this, I'll get the same 2 minus 3i. The down part, just square the one having negative because you are multiplying by its conjugate. So it is 2 squared minus 3i, then I squared. I'll end up having 2 minus 3i divided by 4 minus 9, I squared is negative 1. So I'll have 2 minus 3i divided by, this is going to be plus now, so we'll have 13. It will be 4 plus 9, which is 13. I'll have 13. So now what I have for the second part, so now I'll have this. I'm multiplying negative 1 plus 3i divided by 10 in the brackets. You multiply this by 2 minus 3i divided by 13, like that. So we start one by one. Negative 1 times 2 is negative 2. Negative 1 times 3, negative 3i is positive 3i. Then 3i times 2 is plus 6i. 3i times that is going to be 9i squared. I divide this, 10 times 3 is, or 10 times 13 is 130. Then I know that this part will give me negative 1, which is negative 2 those two will give me 9i. What else? I'll have now negative 9, then negative, so I can just say is plus 9. I divide this by 130. So I'll end up having negative 2, that is going to be 7, then plus 9i divided by 130. So it will be 7 divided by 130 plus 9 over 130i. Is there any number which can go into 7 and 130? I don't think so. Does if I do 130 divided by 17, but I think the one for 9 and 130, I think 3. We try 3. 3 into 130, it leaves a remainder, so I'll leave it there. I'll say my final answer is this, but the question is find the, so the real part z is 7 over 130, and the imaginary z is 9 over 130i. As simple as that. So that is it for the first part. We go to the second part now. So the second part is z is equal to this. The best thing to do this is I'll first multiply this by that, then I'll come ahead and also multiply it by the third one. So 1 times 1 is going to give me 1. 1 times negative 2i, negative 2i. I times 1 is plus I, then I times negative 2i, negative 2i squared. So I simplify this, is going to be 1 minus negative 2 plus I is just I, minus 2, then I have got negative 1. So these two are going to give me plus, which is going to be 3 plus, or 1 plus 2, which is 3, minus I. Now down part here I have this. Like that. So I'm multiplying those two. I'm multiplying those two. So 3 times 1 is going to be 3. 3 times 3i, it will be plus 9i. So this is I. Negative I times I is negative I. Negative I times 1, sorry. Then negative I times 3i is negative 3i squared. Remember, on top here we have 1. So we have 1 divided by 3 is going to be 3 plus 3, because this is going to give us plus of, because of the I squared, so it's going to be 9. Then this is going to be plus 7, 8 I. So I now have 1 over 9 plus 8i. I conjugate this, I'll end up having 9 plus 8i, 9 plus 8i. The top part we have 1, so it will just be the same. Then down part, multiply the one having negative. In this case, I'll multiply this, and I'll end up having 9 plus 8i divided by 9 squared is 81 minus 8 squared is 64. Now I squared is negative 1. So I'll have 9 plus 8i divided by 81 plus negative negative is going to be plus 64. 9 plus 8i. So what is 81 plus 64? That is 145. So the final answer is 9 divided by 145. Then I have plus 8 over 145i. Is there a number which can go into, maybe we try 3. What is 145? 145 divided by 3 it leaves a remainder. What of 9 itself? 145 divided by 9 itself, it leaves a remainder. So this one I'll leave it the way it is. What of 8? I don't think so. So I'll end up there. So I'll say my real part is 9 over 147 or 145. Then my imaginary part is 8 over 145i. As simple as that. So that is it for question 2. Now we're on question 3, which is saying find the values of a and b for which 2a plus 3i is equal to 6 minus ib. Now in this case, this one is very simple, but there is a part where we have complicated equations. I think that should be question 3. I'll explain it. Okay, that should be question 4, sorry, not 3, because this is question 3. So I have 2a plus 3i is equal to 6 minus ib. What we need to understand is that the part which is having a and b, they're supposed to be to the same side. The part which doesn't have a and b should also go to the same side. So I'll shift ib to the other side. I'll have 2a plus ib to be equal to 6. If I shift 3 to the other side, it's going to be minus 3i. What does it mean? This is the real part and this is the imaginary. At the same time, this part we have got, this is the real part, this is the imaginary part. So we equate the real part to each other, the imaginary part also to each other. What does it mean? I'll say 2a should be equal to 6. Then I solve for a. Divided by 2, divided by 2. A will be equal to 3. At the same time, I equate the imaginary part equal to the real part, or the imaginary part. So I've got IB is equal to, now you get the sign. In this case, it's positive. That's why I'm just getting positive here. Is equal to negative 3i. I and I will go. So I'll have B is equal to negative 3. Sometimes when you're getting this, they will tell you to say ignore I. But it's the same thing because I will cancel out. So in this case, A is equal to 3 and B is equal to negative 3. As simple as that. So let's talk about quadratic equations of complex numbers. So this is a very interesting subtopic under complex numbers, and we need to understand it because you are going to be asked several questions in a test or in an exam. So I have the first question. We know that the quadratic equation is in the form of ax squared plus bx plus c is equal to 0. And now in this case we are using z. So z is acting as our x. Okay, in this case. So the best thing to do here is we're not talking about complex numbers like the way this question is, but which is z squared minus 4z plus 5 is equal to 0. This cannot be factorizable. Why? Because it's a complex. We're talking about a quadratic complex numbers, okay, equations. So when you put them in a square root, you discover to say sometimes you end up having maybe negative, and which we know that sometimes we call it undefined, but in this case, since it's a complex number, it's not going to be undefined. Okay, so we use the same formula. We'll say z will be equal to negative b plus or minus the square root of b squared minus 4ac. I divide everything by 2a, like that. So one thing we have to understand is that b in this case is this one, negative 4. Okay, so I'm going to put, since it's negative, meaning it's going to be positive 4, so it will just be 4 plus or minus the square root of negative 4 squared minus 4. The value of a is 1. Here, a number in front of z squared is 1. Then c is 5, like that. And then what are we going to have? We're going to have, we divide this by 2, a is 1. So the next thing, we'll have 4 plus or minus the square root of negative 4 squared is 16 This is going to give me 20. I divide this by 2. So I'll continue this from this side here. I'll say this will be equal to 4 plus or minus the square root of, now I'll have the square root of 16 minus 4 is negative 4, divided by 2. So what is, when I'm talking about complex, if it's a normal quadratic equation, the square root of negative 4, it is undefined. But this is under complex numbers where we have the imaginary, we're just imagining in this case. So the square root of negative 4 is 2i. So I'll say 4 plus or minus 2i divided by 2. So z, since it is squared, we expect to have two answers. So we'll have 4 plus 2i divided by 2, or z can be equal to 4. Now I'll use minus 2i divided by 2, like that. So the final answer in this case is going to be 2 into 2 here. If I want, I can just factor out anyway. I can factor out 2. So I have 2 plus I divided by 2, or z will be equal to, even here, 2 minus I divided by 2. So 2 and 2 can go. So my z will be equal to, so these two can be cancelled out. So I'll have the first z will be 2 plus I divided by, oh, it's just 2 plus I, just like that, divided by 1, but in that case we don't consider 1. Another z will be equal to 2 minus I. So in this case the value of z is 2 plus I or 2 minus I. As simple as that. That is it for the first part. So that is for quadratic equation, the under complex numbers. Now let's go to part B. So part B, we have 2 z squared plus 2z is equal to -5. Just shift -5 to the other side so that we remain with 0 here. So we have 2z squared plus 2z minus 5, or it's negative now. When I shift it to the left hand side, it's going to be plus 5 to be equal to 0. Then we use the formula, we end up having z to be equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Okay, now let's plug in the values. So what is our b? In this case, our b is, so I'll say this is equal to, our b from our question here, our b is 2. So it will be -2 plus or minus the square root of b is 2. So I'll put 2, I square it, minus 4, a is also 2, then c is 5, like that. I divide this by 4. 2 times 2, which is 4. So we see what we're going to have in the square root. 2 squared is 4. Okay. So I'll have -2 plus or minus the square root of, this is going to give us 4 minus, okay, so 2 times 4, 8, 8 times 5, 40, or you can say 4 times 5, 20, 20 times 2, 40. You divide this by 4. The next thing what we're going to do is we'll have -2 plus or minus, this is going to be the square root of 4 minus this is -36, divided by 4. Okay, so we'll have, I'll continue from here, -2 plus or minus the square root of 36 is 6i, because that is going to give us imaginary, so it's 6i. I divide this by 4, so we'll have z will be equal to negative 2 plus 6i divided by 2, or z will be equal to negative 2 minus 6i divided by 4. Let's factor out 2 on top. Z will be equal to negative 2. Should we factor out 2? Okay, let's factor out 2 and not negative 2. So 2 open brackets here will remain with negative 1 plus here 3i, like that. I divide this by 2, or z will be equal to, again I factor out 2, neg 1 plus 3i divided by 4, like that. Where is this 2 coming from? It's 4. So I'll say 2, this is 4, 2 into 2, 1, 2 there, 2. 2 into 2, 1, here 2. So I'll end up having z to be equal to neg 1 plus 3i divided by 2, or z to be equal to neg 1 minus, so this is minus here, because of that minus here, 3i divided by 2. Now this can be written as the final answer. Now can be written as z is equal to neg 1 over 2 plus 3 over 2i. That is the first answer. Or z will be equal to neg 1 over 2, okay, then minus 3 over 2i, like that. So this is the answer, also that is the answer. So that is it for the second part. Now we move to further quadratic equations involving complex numbers. We go to part 3. Part 3, we have I z squared minus z plus I is equal to 0. Same thing, we follow the same. So we have z is equal to negative b plus or minus the square root of b squared minus 4ac, like that. So I divide this by 2a, like that. Z will be equal to negative, what is our b? Our b is negative 1. This is negative z, so it's negative 1 plus or minus the square root of, since that is also negative 1, it's going to be negative 1 squared minus 4. My a is I. In that case, we have been given that a is I there. Then my c is also I. Okay, I divide this by 2. My a is also I. I'll put I down there. The next thing I'm going to do is z will be equal to negative will cancel. I'll have plus or minus the square root of negative 1 squared is 1. Then minus, here I'll have I times I is I squared, so I'll have 4i squared. So I'll have 4i squared. I divide everything by 2i. Okay, I'll continue from here. So 1 plus or minus the square root of 1. This is now going to give us negative, and negative is going to be plus. So I'll end up having 1 plus 4, because I squared is negative 1. So negative 1 times this negative, it will give us plus. I divide this by 2i. So I'll end up having 1 plus or minus the square root of 5 divided by 2i. The square root of 5, unless I use a calculator, but in this case we're not allowed to use a calculator, so I'll leave it the way it is. Meaning I have z to be equal to 1 plus the root of 5 divided by 2i, or z is equal to 1 minus the root of 5 divided by 2i. But we can't leave our answer in this form, because I should not be on the denominator. The answer has to be in the form of x plus I y. So I'll conjugate the what? The denominator. So I'll say 1 plus the root of 5 divided by 2i, meaning times negative 2i, even here times negative 2i. So negative 2i times 1 what are we going to have? Negative 2i times 1, I'll have 2i, like that. Then here I'll have negative 2. Okay, I'll have negative 2. um yes, I'll have negative 2, the square root of 5, then I. Then we divide this by, there is, you just square the one having negative, meaning it's negative 4i squared. So we end up having negative what? Negative 2i minus 2 root of 5i divided by what? Divided by, this is going to be negative I, or I squared is negative 1. Negative 1 times negative, so I'll have positive 4. So I'll end up having z to be equal to, I can factor out 2 outside. Then I'll have, here I'll remain with I, here I'll remain with the root of 5i. Then divide it by 4. So the first answer will be 2 there, 2 there, 2. So we'll have I minus the root of 5i divided by 2. That's my first answer for z. I also have to work out the second part, which is 1 minus the root of 5 divided by 2i. So I'll do the same, times this. So if I do times, I'll have negative 2i. Again, here is going to be plus 2. You can say 2i times, if we say 2 this, it's the same thing. Even if you write it as this, I root of 5, it's the same thing. But the best way to write complex number is this. I divide this by I square, that one is going to be negative 4i squared, like that. So another answer for z, we expect it to be negative 2i plus the root of, or we have 2, the root of 5i. I should not be in the square root. Take note on that. And then what we should know here is that this is negative 4, and then we have got negative 1, because I squared is negative 1. So I end up having positive down. I can factor out 2 on top. I will remain with this. I divide it by 4. So I can now cancel out 1, 2. 2 there, 2 there, 2. So another answer will be this. So this is the first part of z, and another answer is this. So that is it for part 3. Now we go to part 4, which is a bit complex, but anyway, we'll know how to solve it. So this is what we have, and we know that this is my a, my b, my c is equal to 0. Using the same formula, okay, using the same formula, what are we going to do? So what we're going to have, we're going to have, I'll use the same formula. I'll say b, or z, is equal to negative b plus or minus the root of b squared minus 4ac divided by 2a. I want you to follow me on this one. So b in this case is 1 minus I. So I'll say negative 1 minus I, that is my b plus or minus. Inside here I have got 1 minus I, that is my b, but it has to be squared, minus 4. Now my a is 1. What of my b, or my c? My c is negative 3i, like that. Now let's first expand 1 minus I, which is squared, which is, this is the same as 1 minus I, again times 1 minus I, like that. So I times I, or sorry, 1 times 1 is 1. 1 times negative I is negative I. Then again negative I times 1, negative I times negative I squared. So we'll have 1 minus 2i. Then this is going to give us minus 1, and 1 can go. and we end up just 2i. So this part can be replaced by negative 2i. That's all. Remember, down part, a is 1, so it's 2 times 1, like that. And then I'll end up having negative 1 minus I plus or minus the square root of this part here is going to be um it, we have simplified this one to what? Negative 2i. So I'll replace this with what? Negative 2i. Then minus, this is going to be minus minus, so it's going to be plus now. Okay, it's going to be plus. So this is going to give us what? 4 times 3 is 12. I divide this by 2. Okay, so I can get rid of this to create space, and I'll continue from here. Negative 1 minus I plus or minus, so the square root of negative 2i plus 12 is 10i. Divide this by 2. When you reach at this point, we don't know what the square root of 10i is. So the moment I is appearing in the square root, this is what you do. So you say, let the square root of I, the square root of 10i, to be equal to a plus bi, because we know that a plus bi is a complex number where a and b should be the member of real numbers. So when you are trying to work out these two, if you discover that a or b is giving you a complex, then you leave it. We are saying that where a and b is a member of real numbers. Okay, not it's not including the imaginary. So we are only interested in the real part. A and b is what? Real numbers. And then I need to find now the value of a and b. When I find the value of a and b, that will be now the square root of 10i. What do I mean? So you just let what is in the square root, you get what is in the square root equal to a plus bi, where a and b are real numbers. Now we are trying to find the values of a and b. When I find the value of a and b, then I'll come and replace it here. Okay, so I'll say I can square both sides. Even here I square, meaning I've got 10i to be equal to a times a is a squared, a times b is abi, then bi times that is plus abi, b times bi times bi is bi squared. So b, everything has to be squared in this case. Okay, so we have 10. Now one thing we have to remember here is the same as we have got the square root of 0 plus 10i. In this case the real part is 0, the imaginary is 10i. If you have got a number, just a number 2, it's the same as you have got 2 plus 0i, meaning imaginary in that case is 0. Okay, so one thing we have to remember is that this is going to be a squared plus these two can be added to abi. Then now since here I've got is going to be b squared I squared. I squared is negative 1. So I'll replace this with 10i will be equal to a squared. Now that is going to be minus b squared plus 2abi. Now you start comparing with the coefficient now. Okay, with the left hand side. So here I've got the real part which is 0. So I've got 0 plus 10i to be equal to a squared minus b squared plus 2abi. In this case, this is the real part, 0. Again here, these two are the real parts. This is an imaginary part. Again here, 10 is an imaginary part. So we equate them equal to each other. So we say a squared minus b squared is equal to, the real part in this case is 0. Okay. Next thing I'm going to say, the imaginary part should be equal to abi should be equal to 10 and I can go. So in this case, we are just saying 2a b is equal to just 10, just like that. So you can ignore the I for now. If you want, you can just say 2a b is equal to 10. But remember, we are finding the value of a plus bi. Now, in the second, so this would be my equation 1, this would be my equation 2. In the second equation, I can make anything to be the subject of formula, but the best thing, let's just make b as a subject of formula. So it's going to be, I will divide both sides by 2a. So it will be, b will be equal to 10 divided by 2a. So b will be equal to, I'll have 5 over a. I can get rid of this. Meaning, in the first function, in the first equation, sorry, where there is b, we are going to replace it with 5 over a. So I'll say a squared minus, where there is b, we put 5 over a, but we square it, should be equal to 0, like that. Now we can clearly see that we'll have a squared minus these two we're going to have what? We're going to have 5 squared is 25 divided by a squared is equal to 0. I can do times a squared everywhere. What do I mean? Why am I going to do this? To get rid of the fraction. So it will be a raised to the power 4 minus these and these will cancel, those two. So I'll end up having 25. 0 times a squared is just 0. Okay. Now, the best thing here to do is this. I'm going to show you a very simple and straightforward formula. When you reach at this point, one thing you have to know, just say let me show you two methods. If you want, you can shift this to go to the other side. So you say a will be equal to 25. Okay, so the fourth root, a to the power 4 is equal to, it's going to be plus or minus same as the square root, fourth root of 25. What is the fourth root of 25? The fourth root of 25 is going to be the square root of 5, because the square root of 5, the square root of 25 is 5. Again, the square root of 20 of 5, which is just the square root, plus or minus 5. But if you don't understand here, the best thing here, what we can do is this. Let me show you this. Since we have got a to the power, we have got a to the power what? 4. Just say let x is equal to a squared. Okay, and you know that this can be written as a raised to the power 2, again squared minus 25 is equal to 0. I no longer need this part, I think. Yes. So where there is a squared, replace it with x. So it will be x squared minus 25 is equal to 0. Remember, we said where a and b should be real numbers. So this is the difference of two squares. So it will be a x minus 5, again x plus 5 is equal to 0. When you reach at this point, now replace x with a squared. So it will be a squared minus 5, then a squared plus 5 is equal to 0. So this will be a squared is equal to 5, and then a squared is equal to negative 5. So this is going to be this part here. It will be a will be equal to plus or minus, it will be plus or minus the root of 5. Then this one is going to be a plus or minus the square root of negative 5. This is going to give us a complex, because the square root of negative 1 is not a real number. It is undefined. But we said where a and b should be the real numbers, so then this one doesn't exist. You leave it there. So the only solutions for a for now is just this, those two, plus or minus 5. Now, after finding these two, what should we do next? The next thing I'm going to do now is I have to find the value of b. Okay, so I'll say b will be equal to, if I put plus, okay, I have got 5 on top. If I put plus the square root of 5, I'll just have this. At the same time, I can rationalize the denominator to remove the sad on the denominator. That is if I want. Okay, so in this case, I'll just multiply both sides by the square root of 5, even here by square root of 5, to get rid of the sad down here. So I'll end up having, if you want, you can leave it the way it is, just like this. It's fine. In fact, let me just leave it like this. If you want, you can rationalize the denominator. That is just okay as well. Okay, so we end up having b to be equal to 5 over the square root of that. At the same time, but anyway, let's just rationalize the denominator to make things simple. Okay, even here b will be equal to, so now I'll say it is 5 the root of 5 divided by, this one will be the square root of 5 times 5 is 5. 5 and 5 can go, so we'll have the root of 5. Again, if I plug in negative root of 5, I'll still have the same negative root of 5, like that. Try it out. What does it mean? I've got two answers. I have got plus or minus, okay? I've got plus or minus the root of 5, okay, plus again the root of 5. So this is my I. Remember, this is my A, this is my B. B has, where there's B, we need to include what? I. Now, since this is our final thing, remember we are interested in this. This is where we left it, this part here. Where there is the square root of 10i, the answer is this. But because here there is plus or minus, again here there is plus or minus, you ignore one part. So in this case, I'll just leave this and plug in square root of 5 there. Okay, I'll come here. What do I mean? I have got two answers, but you ignore one plus or minus, because here I also have plus or minus. It's the same as this plus or minus. Okay, so I'll say z will be equal to negative 1 minus I plus or minus, I'll ignore this plus or minus, then I'll just put in the brackets the square root of 5 plus the root of 5i, like that. I divide this by 2. Now I go ahead and find my final answers. So in this case, we'll say z will be equal to, I open the brackets, it will be negative 1 minus I. Here I'll use plus now in between, plus c, the square root of 5, again plus the square root of 5i. Divide this by 2. Or z will be equal to, again, negative 1 minus, no, this has to be plus. This time that should be plus. So what I mean is this should be plus, because negative 1, this is negative 1, yes, but that one should be plus now. So for negative, this is going to be plus I, and then minus, okay, that is the first part which we have. So we end up having what? We end up having minus the root of 5, again minus the root of 5i, everything divided by 2. Remember, each part need to have the real part and the imaginary part. So the final answer for z will be negative 1 plus root of 5 divided by 2, okay, then plus I plus root of 5i divided by 2. That's the first answer. Or z is going to be equal to, this will be negative 1 minus root of 5 divided by 2, then plus I minus root of 5i divided by 2. That's another answer. So that is it for this question. Now let's try to solve the last one under equations of complex numbers. So the last one is this question here. So I'll still use the same. This is A, B, this is C. So I'm going to have Z to be equal to uh, negative B plus or minus the square root of B squared minus 4AC, everything divided by 2A. So let's see. Our B is 2 minus 3I, so we'll have negative 2 minus 3I plus or minus the square root of, again our B is 2 minus 3I, now we square it, minus 4, our A is 3. Okay, our A is 3, then our C is negative 1 plus 3I, like that. Everything divided by 2, our A is 3, like that. The best thing to work out this one is to expand this part. So 2 minus 3I is the same as 2 minus 3I, again 2 minus 3I, like that. So 2 times 2 is 4. Okay, then 2 times 3 is negative 6I. 3 times this, negative 6I as well. Those 2 plus 9I squared. So this is 9I squared, same as negative 9. 4 minus 9 is negative 5 plus 12I. Okay, that is what I have now. So I'm going to have negative 2 minus 3I plus or minus the square root of, this is going to be, everything there has been simplified to in the brackets, 5 minus 12I, minus 12I, then minus, this is going to be negative 12. So negative 12 times 12, what are we going to have? Negative 12 times 1 is plus 12, not 12I but just 12 because there's no I there. Then negative 12, this is going to be also plus, so it's going to be 12 times 3, which is going to be 36I, like that. Then we divide this by 6. Again, here we have, if I factor out, if I open the brackets, it's going to be negative 2 plus 3I here, then plus or minus, in the square root here we have, this is negative 5 minus 12I plus 12 plus 13 or plus 36I, everything divided by 6. Now I don't have space, I'll get rid of this part. And then I'll say Z will be equal to negative 2 plus 3I plus or minus the square root of negative 5 plus 12, that should be 7. Negative 12I plus 36I, that is 24I. Everything divided by 6. Now I can get rid of this. At this point, what we need to understand is that we need to find the square root of 7 plus 24I. So you say let the square root of 7 plus 24I to be equal to A plus BI. So we're trying to find the value of A plus BI, where A and B are members of real numbers. One thing we have to understand here is that we have to square. The square root is going to be removed. 7 plus 24I is equal to This one is a times a squared, then it's going to be a b plus b times bi times a b I plus b I. Now those are supposed to be squared, so it will be 7 plus 24i to be equal to, I'll have a squared. Again, this is b squared, but there's I, so it's minus b squared. It's the same as the equation we are from solving, so the equation will be the same, 2ab. Now this is the real part, should be equal to these two. This is the imaginary part, should be equal to 2ab. So I'll say a squared minus b squared should be equal to 7. That is equation 1. 2ab should be equal to 24, like that. So for this, I can make b as a subject of formula. What are we going to do? I'm going to divide both sides by 2a, even here 2a. b will be equal to 12, should be 12a. Okay, so 12 over a, like that. So in the second equation, where there is a squared, where there is b, I'll put 12 divided by a. Now I square it is equal to 7. So this will be a squared minus 12 times 12 is 144 divided by a squared is equal to 7. To get rid of this fraction, which is a squared, do times a squared everywhere. A squared times a squared is a to the power 4 minus, these two are going to cancel out. I'll have 144 is equal to 7a squared. Shift a squared to the other side, that will be more like a quadratic now. So I'll have 7a minus 144 is equal to 0. That is the equation we have right now. Now that I have a to the power 4 minus 7, this is supposed to be 7a squared because it was like this. Okay, divided by, this was a squared is equal to 7a, or is equal to 7. So I was multiplying everywhere by a squared. That's why I'm saying this is 7a squared minus 144 is equal to 0, like that. Now the next thing, we know that a squared is going to be bit complex for us. The best thing to do is let x to be equal to a squared. So where there is a squared, put x. F to the power 4 is the same as a to the power 2 times maybe 2 minus 7 a squared minus 144 is equal to 0. So I can replace where there is a squared with what? With x. So it will be x squared minus 7, where there is a squared, put x. This squared now is the one which is on top here. Okay, then minus 144 is equal to 0. Now this is a quadratic equation, so we have the product as negative 144, the sum to be negative 7. What are the factors? Okay, so the factors are negative 16 and positive 9, because negative 16 times positive 9 is negative 144. Negative 16 plus 9 is negative 7, so it's negative 16 comma plus 9, like that. Those are the factors, meaning is x minus 16, again x plus 9 is equal to 0. But remember, we said where there is, we had just to let x to be equal to a squared. Where there is x, let's replace a squared. So it will be a squared minus 16, even here a squared minus or plus 9. But remember, we said where a and b should be the real numbers. Okay, what does it mean? What it means there is that I have got a squared minus 16 is equal to 0. So a squared will be equal to 16. So the square root of a is plus or minus 4. Okay, I'm done with that. Now, what if I work out with this? A squared will be equal to negative 9. It's not, we can't square a number and get negative 9. No. Okay, in this case we are dealing with only real numbers now when we reach at this point where we are letting. Okay, therefore this can't work out. So I'll only work out with the a is equal to plus or minus 4. Now that a is equal to plus or minus 4, I need to find the value of b. I'll come back here and say we had to make b to be equal to 12. So b was equal to 12 divided by a. Where there's a, let's start with what? Let's start with the plugging in positive 4. So b will be equal to what? Will be equal to 3. Done. Again, b will be equal to, if I put negative, so 12 divided by negative 4, I will have b is equal to negative 3. So I've got two answers. Okay, I have plus or minus open brackets 4 plus 3 I, like that. Now this is a, this is b. It's the one we are trying to find now here. So the square root of 7 plus 24i is plus or minus 4 plus 3i. Now since I've got plus or minus here, I also have plus or minus here. I have to ignore this plus or minus and just plug in this there. Okay, so I'll continue here and say I no longer need this part here. So the best thing now I'm going to do is I'll say is equal to negative 2 plus 3i, then plus or minus, I'll ignore this plus or minus and say open brackets. The square root of this is what we have found, 4 plus 4 plus 3i, like that. So I'll divide everything by 6. Okay, now the next thing what I'm going to do here is I can open the brackets. So I'm going to say negative 2 plus 3i, then I can now use plus. So it's going to be plus 4 plus 3i, everything divided by 6. So another answer for z or z will be equal to, now I'm going to use negative in this case, negative 2 plus 3i minus 4 minus 3i. I divide everything by 6. Then now we can add negative 2 and this, which is going to give us positive 2. Okay, so it will be 2, and then these two guys is going to give us 6i. I divide it by 6. Or z will be equal to, I can add again these two, it will give us negative 6. And then I can clearly see that this and this will give me 0. So I'll just leave it and say divided by 6. So I'll say z will be equal to, I can factor out 2. I'll have 1 plus 3. Okay, or in fact what I can do here is I can just say 2 divided by 6 plus 6i divided by 6 for the first part, and another one, z is equal to negative 1. So it will be z will be equal to, this is 1 over 3 plus this is I for the first part. The second part is that z is equal to negative 1. So in that case where we have only negative 1, the imaginary part is 0i. Okay, so that is what you need to know under solving equations of what, quadratic equations involving complex numbers. So that is it for equations.
Alright, so if you're looking to full solutions to the tutorials that you have, basically the calculus one, for example, you see that all the questions have been answered and are available on our site, all the way up to question 11. And of course, the same applies to the other part, the other tutorial sheet, which is on complex numbers. You notice that they are also solved here. You can see the questions all the way up to question 9. So you can actually access all these by just registering on our site. So in addition to that, you can also learn all the other topics that you need to prepare for in your assessments. Okay, so you need to learn limits, videos are here, differential calculus, and also the complex numbers. So all you just have to do is just go to learn.transcendedinstitute.net, and of course every information is in the description on how to go about the registration process. So the same applies to the other courses, chemistry, physics and biology. The theory solutions are available on our site at a very affordable fee of only 80 kwacha per course. All the best as you rate your assessments.
Alright, so we'll go over some interesting questions under limits. So let me just show you the questions we're going to answer. So you can check question 1. We just have a few questions we have to simplify. And then look at the others. Question 2. Question 2 as well, we're simplifying. Question 3, question 4, first principle. And then we have, these are other questions that have been answered under differentiation as the O topic. So watch a video to the end to understand all these concepts. So let's start with the limits part, the very first one. Okay, very interesting. So that's basically where we're going to start from. Okay, so evaluate the following limits. So for the very first one, how do we handle it? I believe at this point you already watched the video where I've explained the concepts under the limits. If you've not, the link is in the description below. So the limit as x approaches 5, and then we have 2x squared minus 3x plus 4. So each time you're given a question to deal with a limit, just substitute the value you have. Don't only substitute if it's going to give you an error. Now in this case, if we substitute the 5, we're going to have the limit as x approaches 5, and then we're going to have 2, where there's x, we're going to put the 5. Okay, so that's what I've done. Whether we had x as well, I've substituted this 5. So at this point, 5 squared is 25 times 2 is 50 minus 15 plus a 4. So that's going to be 50 minus 11. That's going to be a 39. Okay, so that's how we simplify the limits. That's how we've done the first one. Okay, let's move. Now if we go to part 2, things begin becoming interesting. Here we have the limit as x approaches negative 2, x to the power 3 plus 2x squared plus 4 over 5 minus 3x. How do we simplify this limit? How do you go about it? So basically, let's try to understand what we can do. Does it have an effect if we're going to substitute the value of negative 2? Okay, so let's try. So while there is x, we're going to put the negative 2 on top, so we're going to have negative 2 to the power 3 plus 2. Where there is x, again we're putting a negative 2. Okay, and then on the bottom, where there is x again, where there is 3x, where there is x, we're going to put a minus 2. Let's see. So at least on the denominator we don't have a 0. On top, what do we have? So negative 2 the power 3 is going to be a minus 8. Negative 2 squared is positive 4 times 2. That's 8. And then we have plus 4. Negative 2 times negative 3 is going to be a positive 6. So 6 plus 5 is 11, right? So this is going to subtract, and then we have a 4 over 11 as our result. So the key concept is when you're raising a number, negative 2 to the power 3, it means negative 2 times negative 2 times negative 2. So that gives us a minus 8. Okay, so we just substituted directly because there was no error that we were getting. So with what you've learned, feel free to pause the video and try out the next one. So the third one, here we have the limit as u approaches negative 2. So the square root of u to the power 4 plus 3u plus 6, right? So this is what we have. We have to evaluate the limit as u approaches that. Now the question is, are we going to get any error? Let's substitute. So the limit as u approaches negative 2. So where there is u, we're going to put negative 2. So negative 2 to the power 4 plus 3. And then negative 2 where there is u plus a 6. So what do we have? So negative 2 to the power 4 means negative 2 times negative 2 times negative 2. That's going to be positive 16. Okay, and then that's going to be minus 6 plus a 6. So you notice that 6 will subtract, so you remain with just a 4 as a result. So that's the limit. Simple and straightforward. Simple and straightforward concepts. Now we're on number 4. Number 4, here the limit as x approaches 2, x squared plus x minus 6 over x minus 2. Now this is a part where if you substitute a 2 where there's x, you begin to have the denominator now becoming a 0, which makes the whole expression to be undefined. So at this point, what we usually do is ensure you factorize. Okay, so x squared plus x minus 6, that can be expressed as its factors. So let's look at what we have. The product is 1 times negative 6. The product is negative 6. The sum is the coefficient of the middle part, which is a 1. What two numbers can you multiply to give you negative 6? You add them, they give you 1. So that should be 3 and a 2. So negative 2. So that it will give us a negative 6, and then when you add, we get a positive 1. So if you've got a coefficient of a 1, then you're going to have just x plus 3 and x minus 2, since these are your factors. So we'll just add x. This only applies when the coefficient is a 1 of x squared. If not, then just substitute on the middle part with 3x and minus 2x. And then group them, and then factor out, you still get the same result anyway. So at this point, this is reducing to the limit as x approaches 2. We've expanded it to x plus 3, x minus 2. That's for the numerator. The denominator is 2x minus 2. So we're trying to do away with x minus 2 because it's making the denominator to be undefined. So we can divide, and then we remain with the limit as x approaches 2. And then we just have like x plus 3. So at this point, you know, when you plug in a 2 there, you're going to get the 5. So that's the limit, right? Simple and straightforward. Now we'll proceed. We're on the next one now. So the limit as t approaches 5, and then you have x minus 5 over x squared minus 25. So how do you handle this one? So equally this one, if you're going to substitute in the t, I think this is an error. So you can't have a t and then we're having x. So let's just say it's x. So x approaches 5. So you're going to see that you're going to get a 0 over a 0. This is undefined. So equally here we're supposed to, here we'll apply a difference of 2 squares, since we know the limit as x approaches 5. For the top part we have x minus 5. The denominator we have x squared minus 25. So that can be expressed as 25 is the same as 5 to the power 2. And then we have the limit as x approaches 5. So a difference of 2 squares implies you can come up with 2 of them and then just change the sign. So we can have x minus 5 and then also x plus 5. That's what a difference of 2 squares is called. So even in a case where you have x squared minus 1, it can still be expressed as x squared minus 1 squared. And then as a difference of 2 squares, you can have x minus 1 and then also x plus 1. Very important. So you can clearly see equally here you can divide, so on top you're going to remain with a 1. And so therefore you have the limit as x approaches 5, 1 over x plus 5. So if you put a 5, you're going to have 1 over a 10 as your solution. Okay. So we were done with number 5. The next one. So how do you determine the limit as x approaches 7, root of x plus 2 plus 3 over x minus 7? Now this is a very funny question. Why? Because if you're going to plug in again there, it's going to be unusual. Now feel free to pause the video and try it out. Now you will notice that this one is different in that you can't factorize what is on top. You can't factorize what is on top. So there is no way you're going to cancel out this part. Okay? There is no way you're going to cancel it out. You can try to multiply by the changing the sign, everything. This is not a sad, so still it won't work. So we just apply L'Hopital's rule, which tells us that if you're going to have something like this, if you differentiate the top part and the bottom part, try if it's going to work. So let's try to differentiate the numerator and the denominator. So for the numerator, what's the derivative of what we have? So the expression we have is like x plus 2 square root is the same as the power half plus a 3. So how do you differentiate that? So the derivative there is going to be, we're going to apply the chain rule. So 1 times half is half. Reduce the power by 1, it becomes negative half. The constant will disappear. So whenever you've got a negative power, you can take it to a denominator so that it becomes a positive power. So you have x plus 2, the power half. Now you know that half is the same as the square root, so it's going to be 2 root of x plus 2. That's for the top part, so we have a limit as x approaches 7. So after differentiating the top part, you have 1 over 2 root of x plus 2. Now for the denominator, what's the derivative of x minus 7? So it will just be a 1. Now you notice that the 1 basically doesn't have any difference. So ultimately all we have is just this part remaining anyway. So at this point we're at liberty of substituting. That's if it's not going to be undefined. So we're going to have 1 over 2 root of, where is x, we're going to put a 7 plus 2. So we have 1 over 2 root of 9. So we have 1 over root of 9 is 3. So 2 times 3. So you end up with 1 over 6 as the limit for this beautiful question. Okay, let's move on. With what we've learned so far, feel very free to pause the video and just try out the next question. So how do you handle the limit as x approaches negative 4 for x squared plus 5x plus 4 over x squared plus 3x minus 4? How do you handle this one? So obviously, to make things easier, we are just going to factorize in advance even before trying out anything. So it's possible we may get a 0. Let's try the denominator. The denominator is going to be negative 4 squared plus 3 times negative 4 minus 4. So this is going to be a 16. That's going to be a minus 12 minus 4. So this is actually a 0. So we can't just substitute directly. So let's try to factorize what we have. So the first one, the numerator is x squared plus 5x plus 4. The product here is a 4. The sum is a 5. Think of two numbers that you can basically multiply to give you a 4. You add them to give you 5. So basically we have 1 and a 4. 1 times 4 is a 4. 1 plus 4 is 5. So whenever you've got a coefficient of a 1, so you're going to have x plus 1 and then x plus 4 directly. Okay. So the limit as x approaches negative 4. So for the top part we have x plus 1, x plus 4. We can look at the denominator. Feel free to pause the video and factorize it. So we have x squared plus 3x minus 4. What's the product? The product here is a minus 4. The sum here is a 3. So the product, multiply the coefficient of x squared and the constant, and then the sum, get the coefficient of x. So what two numbers can you multiply to give you negative 4? You add them to give you a positive 3. So obviously that would be a 4 and a negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is positive 3. So I've got a coefficient of 1, so it's just going to be x plus 4, x minus 1. So x plus 4, x minus 1. So don't forget we were dividing them. So we factorized both the denominator and the numerator, so we can see that can divide. So we have the limit as x approaches -4. We're remaining with x plus 1 over x minus 1, and then we can beautifully substitute. So on top you're going to have -4 plus a 1, -4 minus a 1, that's going to be a -3 on top. On the bottom that's a -5, so that gives us 3 over 5 as a solution. Interesting, right? Simple and straightforward. Be at liberty of pausing and trying out this next question. The limit as x approaches 2, you have x squared plus x minus 6 over x minus 2 raised to the power 3. Okay, so how do you look at this one? What are we supposed to do? If we're going to go with direct substitution, you notice that the denominator is going to be a 0. So let's try to prevent that. So looking at what we have on top, we have a quadratic, so we should be able to factorize that. X squared plus x minus 6. The product here is -6. The sum is 1. Factors, what two numbers can you multiply to give you -6? You had them give you 1. Should be a 3 and a 2. Now for us to have a positive sum, it means -2 is supposed to be there so that we have a bigger positive number. 3 times -2 is -6. 3 minus 2 is 1. So therefore, after factorizing, you're going to have x plus 3, x minus 2. So what do we have? So we have a limit as x approaches 2, and then you have x plus 3, and then x minus 2 over x minus 2. All this is raised to the power 3. So this and that will divide. So the denominator, which was reading to a 0, has finally been dealt with. So at this point, what we're remaining with is we're remaining with the limit as x approaches 2. Numerator, we have x plus 3 as the only remaining part. Everything else has been cancelled. So plug in a 2. You're going to have 2 plus 3 raised to the power 3. 5 to the power 3. 5 times 5 is 25 times 5 is 125, is it? Okay, so that's what we have as a result there. We are now on question, should be 9. So you're still at liberty of pausing the video. So you have got the limit as h approaches 0 for the square root of 1 plus h minus 1 over h. So here we're now having surds. Okay, we'll apply the concept of the conjugates here. You know that if you're going to plug in a 0 for h, it's going to be a 0. You can't divide by a 0. So we can avoid this by actually multiplying by the conjugate of the numerator. The conjugate implies we change the sign. So I have 1 plus h, we change the sign in between so that we have plus a 1. Whatever you do to the numerator should be done to the denominator. So this applies even if we had done h on top, you could basically do this. Let's see. So whenever multiplying a conjugate and a surd, this applies even to complex numbers. Just multiply the like parts. This times that, the brackets basically are going to disappear. So you're going to just have 1 plus h. -1 times 1 is going to be a -1. On the bottom, we'll not simplify anything. We'll leave them as ai. Product of h plus 1 plus h plus a 1. Okay. At this point, 1 and the -1 are going to subtract. So remain with the limit as h approaches 0. And then you have h over h. Let me basically show this on the next step better off, so that you can clearly see what I'm writing. So what we have here is the limit as h approaches 0. We have h over h, and then in the brackets we have 1 plus h plus a 1. So the h can divide clearly. So therefore you have 1 over root of 1 plus h. So as h, you can plug in a 0 at this point, plus a 1. So therefore what you have is 1 over root of 1 is a 1, plus 1, so that's a 2. So I have 1 over 2 as the result. So just multiply by the conjugate. I think at this point you should be able to answer the next question without any challenges. The limit as x approaches 2, and then you have x to the power 4 minus 16 over x minus 2. So here what we have is the limit. Okay. What you can see is if we're going to substitute directly into the denominator, basically what you're going to see, is you see that we have a 0 in the denominator. So at this point, this I believe we can write it as the limit as x approaches 2, and then we have x to the power 4. 16 can be expressed as 2 to the power 4, right? Over x minus 2. Okay. Now here the question is, can we factorize the, are we able to factorize the x minus 2 so that we cancel it out? Okay. So that we cancel it out. So I think I would apply other concepts like synthetic division. Yeah, let's try synthetic division. So we are dividing x minus 2. So x minus 2, if we are equate it to 0, we'll find that x should be equal to 2. So for synthetic, what you do is you write down your 2 somewhere this side, draw a line, write the coefficients of whatever you have. So here we have x to the power 4, right? So it's down. So I have x to the power 4. So a coefficient of x to the power 4 is just what? A 0. Oh, it's a 1. So 1. And then x to the power 3, we don't have anything. X to the power 2, we don't have anything. X to the power 1, don't have anything. Not until minus 16. So all these will be assumed to have coefficients of zeros. So 0, 0, 0, and then finally we have the constant. So what you do is for the first one, just put it down, and then you'll be multiplying by the 2 now. 2 times 1 is a 2, plus 0 is a 2, 4 plus 0 is a 4, that's 8, that's now 8, so that's now 16, remainder 0. So at that point, what you have after dividing is this. So since we had started with the power 4, this will be the power 3, the power 2, the power 1, and the power 0 as a constant. So what we have after dividing is x to the power 3, 2x squared, plus 4x, plus 8. You can use long division if you want. So what we have the limit as x approaches 2. For the top part, after dividing by x minus 2, which was x is equal to 2, we are getting x to the power 3 plus 2x squared plus 4x plus 8. And for sure, if you are going to divide these, if you are going to multiply the 2, you are basically going to end up with what we had, this one. So x minus 2. So at this point, this is now able to divide, and we can just plug in a 2 for the remaining part. So we have 2 to the power 3, 2 to the power 2, 4 multiplied by 2 plus 8. So 2 to the power 3 is 8. 2 squared is 4 times 2, that is 8 again. This is 8 again. That is 8 again. So the question is 8 times 2 is 16 times 2 is 32. So that's how you handle this question. Simple and straightforward. So we're now on question number 11. So you have a limit as x approaches negative 4. Then you have 1 over 4 plus 1 over x over 4 plus x. So how do you handle this one? So what do? We'll take a step. Let's try to deal with the numerator. Since we've got fractions, I think we can come up with a common denominator there. Why are we not substituting directly? If we plug in a negative 4 as x, we're going to get a 0 on the denominator. So we are trying to avoid that. We're trying to try other ways of dealing with it. So we can come up with a common denominator for the top part. So that can be 4 times x, which is 4x. 4 into 4x is going to be x. X into 4x is going to be a 4. So we know that after multiplying by the ones that are numerators, there will be no difference. So that's why we're just maintaining x and 4. Bottom, we just have 4 plus x. Okay. So that can be written as, of course, don't omit the limit as I have. Yeah, don't just omit it. So at that point, what we have is like the limit as x approaches negative 4. Now it's like we have x plus 4 over 4x, and then we're dividing by 4 plus x. So dividing by something is as good as multiplying by the reciprocal. So that's as good as multiplying by 1 over 4 plus x. So which will just give us the limit as x approaches negative 4. For the denominator, we're just going to have 4x multiplied by 4 plus x. The top part, we have x plus 4. Okay. So x plus 4 and 4 plus x are just the same. They can cancel, can divide. So we have the limit as x approaches negative 4. And then on the top part, we have the 1, bottom we have 4x. You can substitute. So I have is, if an x, we're going to put a negative 4. So you end up with 1 over 16. So it's negative 1 over 16. Okay. That's where we've ended for this question. So there are a lot of ways, as you've seen from the questions we've attempted, there are a lot of ways of you trying to avoid a negative denominator. There are a lot of ways. Now let's look at question 12. Here we have the limit as t approaches 0, and then you have 1 over t minus 1 over t squared plus t. Now this question is very funny because if you try to substitute where we have t, you're going to have denominators of 0. 1 over 0 minus 1 over 0. So we can't simplify those ones. Okay, so what can we do? So let's try to combine them. Let's try to subtract. We see what we're going to have. So 1 over t. Now the other part, if I factorize out a t, I'm going to have t plus a 1. Okay. So just trying to show you that if I'm going to come up with a common denominator there, it means t plus 1 is a common denominator. So if I'm going to divide by t, I'm going to remain with t plus 1. And then if I'm going to divide by the whole thing, I'm just going to remain with minus 1. So we have limit as t approaches 0. So I've just performed basic algebra here. And so what remains, we have the limit as t approaches 0 For the top part, only a t will remain, and then the bottom we have a t and then t plus 1. So we have the limit as t approaches 0. So t over t and then t plus 1. So this can divide. So you now have the limit as t approaches 0, 1 over t plus 1, and then you can gradually substitute. You're going to have 1 over, where there's a t 0 plus 1, so that's the 1, so you just have the 1 as the result. Okay, and then finally the last question under part 1 to do with these basic limits. We have the limit as x approaches 0, then you have x over root of 1 plus 3x, okay, and then minus a 1 separatory, not under the square root. So here you see I gave you an example of question this one, question 9. I said even if it's on top, it's basically the same concept. So you know, if you substitute, you're going to have a 0 on top. So as a good practice, multiply by the conjugate. So 1 plus 3x plus 1. So what you're going to remain with, by the way, feel free to pause the video and try this one out on your own. So the numerator going to remain with x multiplied by 1 plus 3x and then plus a 1. Denominator, you're going to have 1 plus 3x. Since when you multiply the like parts, the square root will go, and then negative 1 times 1 is just going to be minus 1, right? So at this point, you have the limit as x approaches 0. So for the top part, you have x and then root of 1 plus 3x plus a 1. So on the bottom, 1 and 1 can subtract. So you only remain with a 3x there. So for the 3x, the x and the x can divide. So you just remain with a limit as x approaches 0. And then you remain with what's in the brackets. That's 1 plus 3x plus a 1 over a 3. You can gradually substitute the value of 0. So that part will be eliminated. We have a root of 1, which is just going to be like a 1. 1 plus a 1 is going to be a 2 over a 3 as our result or our solution to that limit. Yeah. So this is where question 1 ends. Okay.
Alright, so if you're looking to full solutions to the tutorials that you have, basically the calculus one, for example, you see that all the questions have been answered and are available on our site all the way up to question 11. And of course, the same applies to the other part, the other tutorial sheet, which is on complex numbers. You notice that they are also solved here. You can see the questions all the way up to question 9. So you can actually access all these by just registering on our site. So in addition to that, you can also learn all the other topics that you need to prepare for in your assessments. Okay, so you need to learn limits, videos are here, differential calculus, and also the complex numbers. So all you just have to do is just go to learn.transcendedinstitute.net, and of course every information is in the description on how to go about the registration process. So the same applies to the other courses, chemistry, physics and biology. The tutorial solutions are available on our site at a very affordable fee of only 80 kwacha per course. All the best as you write assessments.
Alright, so we'll continue with question 2. Here we're trying to evaluate the limits that involves the infinity. So first one, the limit as x approaches infinity is what we're trying to look at. and then you have x squared minus 1 over x squared plus 1. So the basic idea that you need to know, and that I believe you've already learned under our discussion, you know that the limit as x approaches infinity, whether infinity or negative infinity, if it's 1 over x or any power of n, this you should know that it's equal to a 0. Why? You can actually try to observe this as you try to increase. If you're going to start from, let's say, 10, try 100, try 1,000, try a million. So you see that as you begin to increase the numbers below there, what do you begin to see? You begin to see that the value is going to be getting closer and closer to 0. So that's what it means. And this is actually true if you try to sketch a graph of any function in that form of 1 over x. Alright, so when you're given a fraction like this one, what you basically do is you need to divide by the highest power. Okay, highest power on both the denominator and the numerator. So this implies that on our next step, we're going to have the same limit as x approaches infinity. So if you check the numerator, what's the highest power? It is x squared. So divide by x squared. So we have x squared divided by x squared minus 1 over x squared. For the denominator, the highest power is also x squared. So divide the entire denominator by x squared. So after we've done that, on our next stage, you say that you're going to remain with x as x approaches infinity. The limit as x approaches infinity. Divide that, you have a 1. Then the other part, you also have a 1, but plus 1 over x squared. So at this point, you are now able to distribute the limit. Okay? So you remain with 1 minus. So where we have the x, that's where we're going to distribute the limit. So 1 over x squared, and then over 1 plus the limit as x approaches 0 for 1 over x squared. So I told you to say, if you're going to have 1 over x and then you've got x approaching infinity, not 0, you understand that they're all going to be equal to 0. So you're going to have 1 minus 0 plus over 1 plus 0. So at the end of it all, you're going to have 1 divided by 1, which just gives us a 1. So the basic idea is the limit as x approaches infinity or negative infinity in the form of 1 over x or x to any power, the answer is a 0. Okay, so that concept is very important and it will help you. It will help you in simplifying. So let's try to see what we can do for the other three. Feel free to pause the video and apply the same concept to the next question. So here we have the limit as x approaches infinity, and then we have 4x squared minus x minus 2 over 5x squared plus 4x plus 1. So for your own information, for people in a case where you have run out of time, just know that whenever you're trying to determine the limit of polynomials being divided, it's just get the coefficients of the highest powers. So coefficient on top is 4, on the bottom it's 5. So that would be your answer at the end of it all. Okay? So you understand that what you're going to do is you divide by the highest power, right? So the limit as x approaches infinity, don't forget our answer, our predicted answer is 4 over 5. So for the top part, you divide by x squared throughout. So you're going to have 4x squared divided by x squared minus x divided by x squared minus 2 divided by x squared. We're dividing by the x attached to the first one. And then for the bottom, 5x squared. So the highest is x squared. So divide by x squared throughout. X squared, x squared. So you remain with the limit as x approaches infinity. So that will cancel. So you remain with a 4 minus 1 over x minus 2 over x squared. There we have a 5 plus 4 over x squared plus 1 over x squared. So you understand that there's this point. This is a point where we're going to distribute this now. So every part that is having x as a denominator is going to be a 0. And so at the end of it, we are going to have 4 over 5. I told you how to distribute in the previous example, so you can show that. So equally for the third one, you do the same. Here we have the limit as x approaches, this is t, as t approaches negative infinity, and then you have t squared plus 2 over t to the power 3 plus t squared minus 2. So for this one, we'll do the same. The limit as t approaches negative infinity, we'll divide by the highest power on top, it's t squared itself. So it will be t squared plus 2, so divide by t squared divided by, so for the bottom we divide by the highest power, which is t to the power 3. So t to the power 3, t to the power 3, t to the power 3. So what we have, so I'll just go the limit as t approaches negative infinity. So on top, divide, so you have 1 plus 2 over t squared. Denominator you have that will divide, so you have 1 plus 1 over t, and then that's a minus 2 over t to the power 3. So all the parts that having a denominator of a t will become zeros. So eventually you just remain with a 1. This is very important. Now we have an interesting one, that's the fourth one, which is dealing with a radical. The limit as x approaches infinity, x plus 2 root of 9x squared plus 1. So apply the same concept of dividing by the highest power, including under the denominator or under the square root. So you're going to have the limit as x approaches infinity. So you have on top divided by x, you have x over x plus 2 over x. Denominator, you're going to have the square root. Now we divide by x squared, 1 over x squared. So we have the limit as x approaches infinity. So this is going to be a 1, so 1 plus 2 over x, and then square root of 9 plus 1 over x squared. So you can distribute now the limit. So every part where we have x as a denominator, it will be 0. So we have 1 on top remaining, on the bottom you have root of 9 remaining, which will eventually be 1 over 3 as a result. Simple and straightforward, right? Alright, so under question 3, which involves now the asymptotes. So just a few things that I want you to understand under asymptotes very, very fast. So we have what we call the horizontal asymptotes, okay? And then we also have what we call the vertical asymptotes. Very important, right? So what is the horizontal asymptote? What's a vertical asymptote? So I'm sure you've seen graphs, the cases where you're going to have a line like this, and then you find that the graph, as it approaches that line, it's not cutting it, it's just getting closer and closer. So this is called a vertical asymptote. So that would be, for example, x is equal to 2. Horizontal ones equally, can give an example of certain radicals. So you find that they won't cut that line like that. That's a horizontal asymptote. It's avoiding to cut that line. Now there's another kind of an asymptote we call a slant or oblique asymptote. This is not neither horizontal or vertical. Instead, it's something that's slant. It can be something like that. And then you find that the graph maybe is like this. Okay, so this is called a slant or oblique asymptote. So there are cases that define when this basically gets to occur, and that's what we need to understand as we answer these questions. So for the vertical asymptote, simple and straightforward, these ones occur when the denominator is equal to 0. In this case, 1 over x when x is 0. If you're going to have 1 over x plus 2, or whatever denominator you're going to have, whenever the denominator is going to be equal to 0, that is going to be a vertical asymptote. Alright? Very important. Simple and straightforward. So vertical asymptotes occur when the denominator is equal to 0. And then the horizontal, asymptote, there are two cases when they basically gets to occur. Two cases. The first case is where you're going to have the denominator being heavier than the numerator. So this is a normal fraction, x plus 1, for example, and then you've got x squared minus 1. You can see that the degree of the denominator is higher than that of the numerator. So you focus on the highest degrees, okay? Irrespective of how big the polynomials you're dividing are, you focus on the highest ones. In this case, we've got x to the power 2 and x to the power 1. So the denominator is, as we can see, has got a higher degree compared to the numerator, right? So therefore, in this case, y is equal to 0 is going to be the horizontal asymptote in every case when the denominator has got a higher power. And then the second case is where they are equal. For example, you may have x, 2x squared minus x, and then 3x squared minus 1. Here you can see that the degrees are the same. So in this case, what you do is you get the coefficients, which are 2 over 3, 2 and 3, which are the coefficients of the highest degrees of both the numerator and the denominator. So this is the other case where you can find the horizontal asymptote. Now, the other case for the slant, as you might guess, the only kind of a fraction we've not talked about is the case where you have an improper fraction. So an improper fraction, something like, I think this is a good example, x squared plus 1 over x minus 1. This is an example of an improper fraction. So in this case, what you do is basically you divide. You can use long division or synthetic division to help you get the quotient, the remainder. Okay? So in such a case, the quotient is what is going to be the equation of the asymptote. An example I would give is if you're going to look at 3x squared minus 2x, if you know how to divide, if you've done your polynomials, try to divide, you see that you're going to get 3x minus 14 as your quotient, and then of course plus 55 over x plus 4. In this case, what you have here, that is an equation of the slant asymptote to this fraction. So these are the cases that you need to understand, and this is that's the summary of how you handle their different kinds of asymptotes, and they help you sketch a graph easy and faster. Starting with the first case, x plus 2 over x plus 3. This is a case where the degrees are the same. Of course, the simplest one is the vertical asymptote where the denominator is equal to 0. So equate our x plus 3 to 0. You find that x is equal to negative 3. So what is your vertical asymptote? Simple and straightforward. For the horizontal asymptote, where you've got the same highest power, same degrees, we said you get the coefficient. So it's 1 and 1. So therefore, the horizontal asymptote is y is equal to 1 over 1, which is a 1. Pause the video, apply the concepts to find 2. For the second one, we have x minus 1 over x squared plus 1. So this is a normal fraction. We said, of course, equate the denominator to 0 to find the vertical asymptote. So x squared is equal to negative 1. So you notice that you can't find the square root of a negative number. So therefore, the vertical asymptote does not exist in this case. There is no case where the denominator can be equal to a 0 because of the power 2 there. So this is not possible to get a real number. So vertical asymptote does not exist. Now let's try to find the horizontal asymptote. We've got a normal fraction, we've got the denominator having a greater power, a greater degree compared to the numerator, because this is 2, that is a 1. So we said there y is equal to 0 becomes the horizontal asymptote. When you look at the third one, you have x squared plus 1 divided by x minus 1. Now this is a case where you're able to divide, right? This is a case where you're able to divide. Let me add on to this as the last one. Let me answer the others. For the fourth one, you can see that the powers are the same. We have got 5x squared plus 8x minus 3, and then you have 3x squared plus 2. So there, what do we do? The vertical asymptote. How do you under vertical asymptote? The denominator equated to 0. So 3x squared plus 2 is equal to 0. You find that you have 3x squared being equal to negative 2, and then of course you can't as well in this case find the square root of a negative number, so we don't have a vertical asymptote in this case either. How do you find the horizontal asymptote? So we've got the same degrees, x squared, so it's going to be 5 over 3. Simple and straightforward. So done with the first one, the second one, the fourth one. This is also division. The last one, we can undo it. So we have x squared minus 3x plus 2, x to the power 3 minus 2x squared. So first of all, vertical asymptote equates the denominator to 0. So x to the power 3, how can we simplify this? So I've got x to the power 3 minus that. How about if you factorize x squared? What are you going to remain with? We're going to remain with x minus 2 equal to 0. So there are two possibilities. It's either x squared is equal to 0 or x minus 2 is equal to 0. Okay? So which is the case actually? If you plug in 2 there, you'll notice that you're going to have 8 minus 8, which will be a 0. If you plug in a 0 as well, it will be a 0. So these are the two possible. These are the two vertical asymptotes. X is equal to 0, x is equal to 2. So when you begin sketching this function, we don't expect it to cut the part where x is 0, which is of course the y-axis, and then x is equal to 2. So it should not cut these two lines. That's what it means for vertical asymptotes. Now for the horizontal ones, what do we do? Horizontal, observe x squared over x to the power 3. So the denominator has got a greater power. So in this case, y is equal to 0 is what? The horizontal asymptote. So therefore, y is equal to 0. Y is equal to 0. By now you should understand that that's the x-axis. So this is the horizontal asymptote. And then we said for the vertical, it's x is equal to 0 and x is equal to 2. So you shouldn't cut these lines. So when you're sketching this graph, it can be something that it's possible it can be something like this, and then it acts like this. I'm just trying to guess, I'm not sure how it's going to come out, but something like that. Okay, so we've identified the vertical asymptotes and the horizontal asymptote for the last one. So we now have the two special cases that will now involve division. So let's see how we can handle them. Okay, so we are now on the case that now requires to divide. So I hope you've learned long division. If you're new to that, just search long division Transcended Institute on YouTube or synthetic division so that you basically get to understand the two. However, I'll explain here. So how do you divide? So we have x minus 1, and then we're dividing into x squared plus 1. So I'll introduce imaginary parts to ensure that the powers are reducing in this order they are supposed to. So 0x is imaginary, and then we have a constant 1. So you can see we have 2, 1, and x to the power 0. So that's what we want. So let's try to divide now. So we'll divide by our x. X into x squared is going to be x. Now multiply that x with whatever is on the left, whatever we're dividing with. So we are going to end up with x squared minus x. And then we'll subtract. This will cancel, and then remain with 0x minus x. That will be positive x. Divide by positive x, again you're going to have a 1. And then you multiply the 1 with whatever is here. You're going to have x minus 1. And then we've got a negative there. You can drop a 1. So x minus x is 0. 1 minus 1, that's going to be a plus 2 because of this negative. Okay, so therefore what we have is we have the quotient is x plus 1, the remainder is 2 over the divisor, which is x minus 1. So therefore, what has this told us? So this tells us this what we have here, the quotient, is the equation of the slant asymptote. Okay, that's a linear, that's a line. And then, of course, the vertical asymptote is still going to be found in the same way by equating the denominator to 0. So we find that x is equal to 1 for the vertical asymptote. Simple and straightforward, right? Feel free to pause the video and try out the last one, 5. So we have x squared minus 3 over 3x plus 4. Feel free to pause the video and try this one out. How are we going to divide it? So we apply the same concepts. Okay, you divide. So we have 3x plus 4, and then we're dividing into x squared minus 3. So you can see here we've got an issue dividing 3x into x squared already. Let's try to apply synthetic division. Synthetic division requires us that we find the value of x by equating whatever we're dividing with to 0. So 3x is equal to negative 4, and then x becomes negative 4 over 3. So we'll use that. That's negative 4 over 3, and then we'll divide it into the coefficients or whatever we have. So we have x squared minus 3. So I'll introduce the imaginary parts. So we have 0x and then minus a 3. So the coefficients that we have there are 1, 0, and negative 3. So 1, 0, and negative 3. Well, how do you go about it? So first of all, drop the first coefficient and then multiply by that. So that would be negative 4 over 3. Add with a 0 to be negative 4 over 3. Multiply by negative 4 over 3 again to be 16 over 9. Now there what you have is negative 3 plus 16 over 9. So 16 over 9 in other terms. 16 over 9 minus 3. Common denominator 9, 16 minus 9 times 3 is 27. So that's going to be a 4 plus a 7, 11. So that should be negative 11 over 9. So negative 11 over 9. Hopefully my calculations are okay. So remember here what we had is x squared as the highest power. So your answers reduce. Okay, the last part is the remainder. So therefore you have x minus 4 over 3 as your factor, as your quotient, and then plus the remainder negative 11 over 9 divided by the divisor. So therefore this is a slant asymptote. Then for the vertical asymptote, as usual, equate the denominator to 0. So 3x plus 4 equated to 0. You have 3x being equal to negative 4. So x becomes negative 4 over 3. That's your vertical asymptote. So that's how you handle question 3 with positivity, confidence.
Alright, so if you're looking to full solutions to the tutorials that you have, basically the calculus one, for example, you see that all the questions have been answered and are available on our site, all the way up to question 11. And of course, the same applies to the other part, the other tutorial sheet, which is on complex numbers. You notice that they are also solved here. You can see the questions all the way up to question 9. So you can actually access all these by just registering on our site. So in addition to that, you can also learn all the other topics that you need to prepare for in your assessments. Okay, so you need to learn limits, videos are here, differential calculus, and also the complex numbers. So all you just have to do is just go to learn.transcendedinstitute.net, and of course every information is in the description on how to go about the registration process. So the same applies to the other courses, chemistry, physics and biology. The Toshi solutions are available on our site at a very affordable fee of only 80 kwacha per course. All the best as you rate assessments.
Alright, so let's handle question 4, which is dealing with the first principle. So I've already explained what the first principle is. So the first principle is the case where they want you to build your derivatives from the very definition of the gradient, where we know the gradient is a change in y over change in x. So change in y as the function of x plus h minus the function itself divided by x plus h minus x, which reduces to f of x plus h minus f of x and then just h. And then of course we add the limit. The limit as h approaches 0. This is basically the first principle. Okay. So everything we're going to be doing will be based on that very equation. So when I look at the very first one, 3x squared, they want me to determine the derivative, find the derivatives in terms of x. So we already know that the derivative there is of course going to be 6x. Now how do we show that using the first principle? So our equation, the limit as h approaches 0. Now don't forget the equation is f of x plus h minus f of x divided by h. Of course don't forget the limit as h approaches 0. So for f of x plus h, it implies where there is x, you put x plus h in the function. So we're going to have 3x plus h where there is x squared, and then minus f of x, which means the original function itself, divided by h. We'll maintain the limit as h approaches 0, and then of course we have a 3. So expand what's in the brackets. You're going to have x squared plus that's going to be 2hx plus h squared, and then minus 3x squared over h. Now next step, we can distribute the 3. So we're going to have 3x squared plus 6hx plus 3h squared minus 3x squared. So this and that can subtract. We're still dividing by the h, don't forget. On our next step, the limit as h approaches 0, you can factor out the h on top so that you have h and then remain with 6x plus 3h over h. The idea is we can't divide by a 0, so the h has to be cancelled. Our goal is to always ensure that the h on the bottom is cancelled out. So you're now remaining with the limit as h approaches 0, and then you have 6x plus 3h. So now at this point, you know that wherever you have h is going to be a 0, so what remains is 6x as your derivative. That's how you use the first principle. Now apply whatever we've done here to every other question ahead of us. The second one is 1 minus root of x minus 1. Differentiate that function using first principle. So obviously I've already told you the limit as h approaches 0. We'll start by f of x plus h. It implies where there's x, you put x plus h. So you're going to have a 1 over root of x plus h minus 1, and then minus the original function itself, which is just 1 over root of x minus 1, divided by the denominator, which is h in our equation. Next step, the limit as h approaches 0. We want to ensure that the h on the bottom is cancelled out. In this case, we have got fractions on top. Let's try to combine them. So common denominator will require us to have a product of the 2. So we have x plus h minus 1 multiplied by x root of x minus 1. Then we divide. If we divide that, we're going to remain with the other part. So we have root of x minus 1 and then minus root of x plus h minus 1. That's basic computations of fractions. Okay, let me ensure you've gotten that. So that's just our numerator. Don't forget we have the limit attached. So the limit as h approaches 0 is attached. For the denominator, we have division by h. In other terms, we're multiplying the entire part by 1 over h. So that's what division is there. What do we do? So at this point, we've seen that we're dividing by 1 over h. Let me just bring it to the denominator so that you can clearly see the next step. So for the next step, what you do is you multiply by the conjugate, just changing the sign in between. Yeah, you understand why. So the conjugate implies we change the sign. So multiply both the denominator and the numerator of a fraction by the top part, changing the sign in between. So that will be root of x minus 1. We change the sign to be a positive, and then x plus h minus 1. Whatever you do to the numerator, do it to the denominator as well. Okay. Now that is going to be a very important step, and I want you to be very familiar to this because this is going to be very useful to even the other questions that follow. So what you do here is, when you multiply this by that, the square root will disappear. You're going to remain with x minus 1. Then this times that as well to be minus, and then the square root will disappear. So x plus h minus 1 will remain. Okay. For the denominator, we will not expand anything because we don't expect anything to cancel out. So we maintain them as they are. In the brackets, we have root of x plus h minus 1 multiplied by root of x minus 1 in brackets. And then we are multiplying with this part. I'll put it in brackets as well. Root of x minus 1 plus root of x plus h minus 1 in brackets. Okay. Now, this entire part is divided by h. Everything is being divided by h. So dividing by h, the entire part there. Now, dividing by h is as good as multiplying by 1 over h for any information. I already mentioned that. Now, let's try to proceed to the next step where we're saying the limit as h approaches 0. Now, for the top part, you have x minus 1. Distribute the negative, you have minus x minus h plus 1. So clearly you can see that the x will subtract with the x there. This positive x will subtract with a minus x. Then the positive 1 will subtract with a negative 1. So essentially what's going to remain is just the negative h on top. And I think I can just show it there that the h is what is going to remain. And then the h will basically divide with that h. In fact, it's the negative h that basically remains. It's negative h. So negative h, and then the h will divide, so you remain with a negative 1 on top. So I have negative 1. Now let's distribute this, the h approaches 0. So wherever we have h, we're going to put a 0. So that part in the brackets, we're going to remain with root of x minus 1. The h has disappeared. And then multiply by root of x minus 1 as it is. And then the next part in the other brackets, it will remain as it is, plus the h will also disappear there, remain with root of x minus 1. So what we have now at this point? At this point now we have negative, let me simplify everything. So we have the limit as h approaches 0, and then you have negative 1. In fact, the limit can now disappear. So we have negative 1 remaining on top. And then on the bottom, what we have is, this times that will make the square root to disappear. So we just have x minus 1 in the first bracket. In the other bracket, this plus that will be 2. So that's a 2 of those coming twice. Everything else has disappeared. So is there any way we can better put this? There is. Negative 1, and then I can start with a 2 instead. And then x minus 1 if I want in brackets, and then root of x minus 1. If I want, I don't have to put it in brackets. But this is basically what you are ending up with as the derivative to the second part. Alright, so we'll continue now with question 3. So that's the function that is cosine 3 of x. We have to differentiate this using the first principle. So from first principles as well, don't forget the equation f of x plus h minus f of x divided by h, right? The limit, of course, as h approaches 0. So what we do, it implies where there's x, you put x plus h for the first part. So the limit as h approaches 0 for f of x plus h implies we put x plus h. Since we're dealing with cosine 3x, where there's x, we're going to put x plus h. Okay, that's the step we're going to make there. So we're going to have cosine and then 3, where there's x, we're putting x plus h, minus f of x, which is of course the function itself, cosine 3x, and then divided by h. This is all we are supposed to do. The limit as h approaches 0, we can distribute the 3. You understand that we're going to have cosine 3x and then plus 3h. You can still put that in brackets and then over h. So we can't substitute the value of h because we've got h as a denominator there, and you know the effect of that, it will make everything undefined. So let's try to expand using our trigonometry. We know our trigonometry at this point. So whenever we've got cosine, I call cosine to be selfish. So it will be cosine 3x, cosine 3h, and then sine comes after. So I have sine 3x, sine 3h, and then minus the cosine 3x there over h. Okay, we're getting there. At this point, what can we do? Do we have anything common that we can... So I can see cosine 3x is common, right? So the limit as h approaches 0, we'll factor out the cosine 3x. What remains? For the first part, we're going to remain with cosine 3h, the other part to just be a 1, and then minus sine 3x sine 3h over h. Okay, at least we're getting there. Now, some of the things that you have to know under the trig limits. You know that if you're going to have something like sine 3x or sine 3h, which we have in this case over 3h, and then apply the limit as h approaches 0, this is equal to a 1. And then for the cosine part, you're going to have cosine 3h minus 1 over 3h, and then the limit as h approaches 0, this is going to be equal to a 0. You know that, right? So let's try to see the way we can come up with this. So let's distribute the limit. So the parts that don't have h are innocent. So I have cosine 3x. We'll now distribute the limit. The limit as h approaches 0 will apply to this part. So what we have cosine 3h minus 1. So as a smart student, divide everything by h. So if you divide everything by h at this point, this part will be over h, even that part will be over h. So therefore that h can apply here, and then minus what we have sine 3x, and then we distribute the limit to the other part. The limit as h approaches 0 to what? So that will be sine 3h over h. So now you know that you can't, the identities we have only applies if this and that, if those ones are matching. So we have to multiply both the numerator and the denominator by the 3 for that to work. So here we'll distribute the 3. So we'll have a 3 on top there, even there a 3. So on the bottom as well we'll have 3's. So what does that mean? So this part is going to be equal to a 0. That's an identity. That part will be equal to a 1. So the first part is going to be eliminated because of a 0. Then the other part you're going to remain with negative 3 sine 3x. Okay, so that's the derivative we're going to have. And that's basically true. Derivative of cosine, it's negative sine multiplied by the derivative of what is attached there. It's a 3. So negative 3 sine 3x is the result we have. Be at liberty of practicing. As a good student, you can try out sine 3x. you know obviously that the derivative there is going to be cosine 3x 3. So make sure you get that using the first principle. Okay. Now on the fourth one, we have a radical again, root of x squared plus 1. So f of x plus h, so let's don't forget our formula. The limit as h approaches 0, so root of x plus h squared plus 1 minus root of x squared plus 1 over h. So all we have is we just distributed in the function. Don't forget our function or our equation, f of x plus h minus f of x divided by h. Don't forget the limit as h approaches 0. So this one is simple and straightforward. You can't distribute h equal to 0 because it's going to make it undefined. So we'll multiply by the conjugate. So that step I'll omit it. So you know that when I'm multiplying by the conjugate, it implies to change the sign in between. So for the numerator, you know that what's going to disappear will be the square root. So we are going to remain with x plus h squared plus 1 and then minus x squared plus 1 over h. Now at this point it implies we had multiplied by the conjugate of the top part, which implied the square root of x plus h squared plus 1, changing the sign in between, and then that is x squared plus 1. Okay, so let's expand that. So that's going to be x squared plus hx plus h squared plus a 1. We'll distribute the negative for the other part to be minus x squared minus 1. Let's identify what's cancelling out. That and that are subtracting. The negative 1 and the positive 1 are also going. What's remaining is hx plus h squared. I can put it there. So h squared plus hx. We can factor out the h. You factor out the h, you're going to remain with x plus h. So these can divide. So our goal is to remove the h from the denominator. So at this point, distribute the h is equal to 0 now. So 0 have is h. What's remaining? So let's try to identify what will remain. So the limit as h approaches 0. For the top part, you remain with x. For the top part, you remain with x over. On the bottom, the h will go, so you remain with x squared. The root of x squared plus a 1 plus root of x squared plus a 1. So eventually, you have x over 2 of these being the derivative. Alright? And then for number 5, y is equal to 1 over x. That one is simple and straightforward. So for f of x plus h, it will mean 1 over x plus h minus 1 over x divided by h. For the fractions, common denominator is x plus h multiplied by x. So if you divide by x plus h, you're going to remain with x. If you divide by x, you're going to remain with x plus h as well. So don't forget the limit as h approaches 0. And then don't forget you're dividing by h as well. So here we're dividing by h. So equally you're dividing by h, of course I did emphasize it's as good as multiplying by 1 over h. The limit as h approaches 0. For the top part, if you distribute the negative, you end up with x minus h, remaining with only a negative h on top. And then on the bottom, you have x multiplying by x plus h. Okay? Now don't forget we are multiplying by 1 over h the entire equation. So h can basically now divide. we are always avoiding dividing by a 0, so that's why this h is always supposed to cancel out. So now at this point, what's remaining is the limit as h approaches 0. You have -1 on top over x and then x plus h. So wherever is h now, you can put a 0. So you remain with -1 over x and then x plus 0. So that will just be -1 over x squared. Okay. And that's basically true. That's basically true if you know how to differentiate 1 over x. 1 over x is as good as x to the power -1. So if you're going to differentiate it, that's going to be -1 multiplied by the x. You reduce the power by 1 to become -2. So you have -1 over x to the power 2. And then for the last one, which is the final one, quite interesting. There we have y being equal to x over x minus 1. Simple and straightforward. Plug in. So the limit as h approaches 0. So for x plus h, it will mean we have x plus h over x plus h. So wherever is x, I've just put x plus h. Now minus the original one, which is x over x minus 1 divided by the h. That's what we have at that point. And so, of course, all the same, common denominator. So common denominator is, of course, x plus h minus 1 and then x minus 1. That's the common denominator. Let me just move it a bit down. And then as you begin multiplying now, you notice that for the first one, if you divide that into this, you remain with x minus 1. So it will be x plus h, which is already there, multiplied by the x minus 1, and then minus the x, which is already there. If you divide that into this again, you remain with now the other part, x plus h minus a 1. Okay, we're getting a step closer. Don't forget we're dividing by h the entire part, so that's as good as multiplying by 1 over h. Are we any step closer? Let's try to simplify what we have. The limit as h approaches 0. So far we've seen that the conjugate multiplication only deals with the radicals, right? Everything else is just working out smoothly. Fractions, just simplify them as you would. So let's try to multiply that. For this fraction, for what? X times x is x squared plus hx, and then that's minus x, and then minus h, is it? And then for the other part, distribute the negative x, so I have negative x squared, negative hx, and then positive x over the denominator remains as it is. We don't like tampering with it, okay, so that we maintain the 1 over h as it is. So our goal is to ensure that on top we remain with h and somehow cancel the one that is out there. So the limit as h approaches 0. Right? So let's cancel out what's common. X squared will cancel, minus hx plus hx, positive x and negative x. What remains is negative h on top, and then on the bottom we have x plus h minus 1, x minus 1, and then 1 over h. So that can also go away. What remains at this point is the limit as h approaches 0, and then negative 1 over x plus h minus 1, and then x minus 1. So whatever is h, we're going to put a 0, and so that will disappear. You have negative 1 remaining over x minus 1 coming twice, so that would mean to be x minus 1 to the power 2. Okay, so I believe if everything, if all our computations are okay, this is the derivative for that other one. But of course you can try it by using the quotient rule. to verify all our solutions. Okay, so this is where we end with question 4. Alright. Alright, so we'll now look at differentiating in terms of x. So we have quite a number here. So we have questions involving the product rule, we have questions involving the logarithms, questions involving the quotient rule, logarithms, product, chain rule, logarithm, product rule. So I'll solve them. So question 1, as you can see, it's a product. So we have x squared multiplied by x to the power 3 plus x to the power 4. So this is a product of two functions. Okay? So let's call the first function to be x squared, and then the other one to be v to be called let's have the other side x to the power 3, right? So we'll call it, our v will be called x to the power 3 plus x to the power 4, right? So now we have to differentiate all these. So u prime is going to be 2x, then on the other side v prime is going to be 4 x to the power 3 plus x. The power has to reduce by a 1, right? We're applying the chain rule to differentiate v. So when the power reduces by 1, it becomes 3. Don't forget you're supposed to multiply by the derivative of what is in the brackets. So that is 3x squared plus 1. Okay. So due to lack of enough space, so let me move it a bit. So that's what we have. So we have applied the chain rule to differentiate v. So a basic idea of a basic argument of the product rule is it doesn't matter what you start with. So I'll start with x squared, and then I'll multiply by the derivative of the other part, which is that. So that is 4, open brackets. So I'll start with the first part, x to the power 3 plus x to the power 3 multiplied by 3x squared plus 1. And then plus, we can now go to the second part, which is x to the power 3 plus x to the power 4 multiplied by the derivative of the very first part, which is 2x. This is what the product rule tells us to do. Now at this point, 4 times that is going to be 4x squared. I can start with that part if I want to, or instead I can factorize. I can see this is common. So what's the highest common? Or maybe if we are going to do that anyway, if we're going to do that, it means let's first of all multiply. So we have 4x squared, and then we remain with x to the power 3 plus x to the power 3, and then we have 3x squared plus 1 in brackets. Now the other part we will have 2x, and then x to the power 3 plus x raised to the power 4. So this is where we've ended. And if you want, you can take an extra step by simplifying the solution by factorizing. You can see x is common. Let me just say 2x is common, right? So you can have 2x. So the very first part, what remains is what? If we pull out the 2x, we remain with a 2x. And then what else can we pull out? Now we can pull out this part. We can see this is common, this is common. So the highest common power is 3. So I have x to the power 3 plus x to the power 3. Now in the brackets, what remains? When we remove 2x from 4x squared, we're going to remain with 2x. And then we're also going to remain with 3x squared plus 1 for the first part. Plus the other part, 2x is already pulled out. And then we'll remain with a single power since 3 has already been pulled. So x to the power 3 plus x. So of course you know what is in the brackets can be simplified, right? So I have 2x, x to the power 3 plus x to the power 3 in brackets. So 2x times that is going to be 6x to the power 3 plus 2x plus x to the power 3 plus x. That's what we have there, right? So now at this point we know the like terms, right? So the like terms are 6x and that. So we are going to have 2x and then x to the power 3 plus x to the power 3 in brackets. So you remain with 7x to the power 3 plus 3x. So you can end here. But you could have ended even just before this, there's no arm. The basic idea is they want to see if you understand what method you're going to use to simplify any given question. So the next one is involving now the natural log. Natural log of 1 minus x squared, 1 plus x squared. So I want you to pay particular attention to what we can do here. So whenever you've got a natural log or any log, they say, the formula is very, very simple. Okay? So whenever you've got a natural log of u, what's the derivative? The derivative is going to be u prime over u. That's all. Very, very simple and straightforward, right? So what that means is, if you're going to have a natural log of x squared, the derivative of x squared is 2x, the derivative, and then you maintain whatever is attached to the natural log x squared. So this gives you 2 over x. That's how you differentiate the natural log. So you can do the same. You can literally do the same here. How? First of all, differentiate this using the quotient rule. Put your answer on top and then divide by itself the way it is. That's one way of handling it, right? Simple and straightforward. Now I don't want to use this method. I want to apply a bit of some logarithms. So logarithms tells us when you've combined the log of two different things that you're dividing, it implied they were sharing what? The log, sharing the base. So I can expand this using logarithms. This is natural log of 1 minus x squared. Now when you're subtracting, it implies, or when you're dividing, it implies you were subtracting. So minus the natural log of 1 plus x squared. So these are just logs. Now at this point, this is going to be easier. Now what's the derivative of what is in the brackets? It's negative 2x. We'll maintain whatever is in the brackets. The other part as well, the derivative of that is going to be 2x. We'll maintain what's in the brackets, 1 plus x squared. So this is simple and straightforward, right? Than going by the quotient rule, which you can also easily do. Okay. Now, of course, if you want, you can simplify this beyond this point. Come up with a common denominator. If you want to find the same answer that you find, if you go the other way. So you want to simplify this, right? So 1 minus x squared plus 1 plus x squared, that's the common denominator. Okay. So after I divide by that, what remains is the other part. So it's negative 2x multiplied by 1 plus x squared, and then minus, and then you have 2x on top multiplying by 1 minus x squared. At this point, what we have, so negative 2x multiplied by that to be negative 2x minus negative 2x to the power 3. This part, negative 2x plus 2x to the power 3 over. So if you check what we're multiplying over the denominator, it's more like a conjugate because the sign is just changing. So it will just be 1 times 1, and then negative x squared times negative x squared will be negative x to the power 4. If you want, you can go step by step, you still end up with the same result. So let's see what's subtracting here. So this part and that part are of opposite signs. So on top we remain with negative 4x over 1 minus x to the power 4. Okay, so that's where you end for part 2. Alright, so question 3 is very simple. Just apply the quotient rule. So feel free to pause the video and try it out. So we have 1 plus x to the power 3 divided by x squared, right? So we are got two different functions dividing, so we'll use the quotient rule. Quotient rule tells us if you're going to have u over v, the formula that you can use is v and then u prime minus u v prime over v squared. Okay, so if we're going to let our u be what is on top, we can go on and substitute in the function or in the equation there. So what is our v? Our v is the denominator, x squared. Now what is u prime? U prime implies you differentiate whatever is on top, right? Because our u is equal to that. So our u is equal to 1 plus x to the power 3. What's the derivative there? So the square root is the same as what? The square root is the same as raising something to the power half. So if we're going to differentiate it, it's going to be half 1 plus x to the power 3, reduce the power by 1, it will be negative half. Multiply by the derivative of what is in the brackets, that's going to be 3x squared, right? So at that point, what we're going to have after simplifying this, 3x squared over the 2 after multiply by the half and that. And then in the brackets, we're going to remain with 1 plus x to the power 3 raised to the power negative half. We know you can take that to a denominator so that you can have a positive power, right? So we can have 1 plus x to the power 3 raised to the power half. Now positive half is the same as the square root. So therefore, our derivative becomes 3x squared over 2 root of 1 plus x to the power 3. Okay, we can continue in the formula. So minus u, so our u is our numerator, so that is root of 1 plus x to the power 3 multiplied by v prime. V prime is the derivative of what is on the bottom, which is going to just be 2x, right? Over, now well, the denominator is going to be v squared, so that will be x squared squared. I think at this point all we are remaining with is just now the idea of us simplifying whatever we have. Can we simplify it beyond this point? That's the question. So this times that is going to be 3x to the power 4, and then over 2 root of 1 plus x to the power 3, right? And then minus the other part. What are we remaining with? So remaining with if you multiply this times that, you're going to have negative 2x and then square root of 1 plus x to the power 3, of course, over what's on the denominator, which is x squared squared, which is going to be x to the power 4. So at this point, dividing by that is as good as multiplying the entire thing by 1 over x to the power 4. So if you multiply the first part by that, you notice that they will divide, right? So you essentially remain with what? You're going to remain with a 3 on top, and then 2 root of 1 plus x to the power 3, and then of course this times that, you remain with only a 2, so minus 2 root of 1 plus x to the power 3, and then on the bottom we have x to the power 3. So basically at this point you are done with the third one. Okay, so let's continue with the fourth one now. So here we have the natural log of 2 plus cosine of x over 3 minus sine of x. So how do we basically get to differentiate this? How do we go about it when it comes to differentiation? So all the same, I would advise you pause the video and try it out. So initially I said you're supposed to expand this, right? When you're dividing, it means if you separate them with the same base of the log, you're going to subtract. So this is natural log of 2 plus cosine of x, and then minus natural log 3 minus sine of x. Okay, so at this point we understand that for natural log, I said whatever is attached, the derivative of it over the original is the derivative. So what's the derivative of 2 plus cosine of x? So you know that the derivative of a constant is a 0. Now derivative of cosine is negative sine. Okay, derivative of sine is cosine. Okay, take note of that. So derivative of cosine is going to be negative sine over the original, which is 2 plus cosine of x, and then minus, for the other part, what's the derivative of 3 minus sine of x? The constant will cancel out. Derivative of negative sine, sine maintains the sign, so if you say negative sine, it will be negative cosine. So negative cosine of x over the original, right? Which is just 3 minus sine of x. So at this point we have negative sine of x plus cosine of x. Okay, this is over 2 plus cosine of x, and then that is 3 minus sine of x. I think this is okay to end at this point. Very, very fine. Okay. So you clearly show that you understand how to go about the logs. You clearly understand how to basically differentiate them. You can go by the other method and see, which will require you to first of all use the quotient rule, determine the derivative of what is in the brackets, and then divide by the same one, 2 plus cosine of x over 3 minus sine of x. So try this one out and see if you're going to end up with the same result. And if not, it means you can basically go on and simplify this beyond this point, which is not necessary. The next one is product rule. So pause the video and try it out. So I've already explained how you basically differentiate an exponential. So how do you differentiate an exponential? An exponential differentiated by multiplying by the derivative of the power. So what's the derivative of negative 3x? That's a negative 3. So therefore, if you multiply by negative 3, what you have is a derivative. Okay? So therefore, if we're going to say that our y will be x squared, u prime is 2x, our v is e to the power negative 3x, therefore v prime becomes negative 3. So notice that for an exponential, the power doesn't change. So therefore y prime, it doesn't matter what you start with, but you need to multiply these. So if I start with x squared, I'm supposed to multiply by the derivative of the other part, which is negative 3, e to the power negative 3x, and then plus, so the other part, e to the power negative 3x multiplied by 2x. So at this point, what's common? Anyway, you can factorize for yourself, so I'll leave it at this point. When you multiply this times that, it will be negative 3x squared e to the power negative 3x, and then the other part will be plus 2x e to the power negative 3x. Now at this point, this is where you can now see what is common, right? You can see that e is common. You can also see that x is common, so you can have x and e being common. And in the brackets, what remains for the very first part, you have negative 3 and an x remaining. Then the other part, you just have a 2 remaining. So that's what you have. That's what you have after differentiating that. Now when you check the next one basically involves just the chain rule. Y is equal to cosine x to the power 3 minus 4. How do you go about it? So our y prime is going to be, ask yourself, what's the derivative of cosine? What's the derivative of cosine? So we say derivative of sine is cosine. Derivative of cosine is negative sine. Just this will help you. So the derivative of cosine is negative sine. So you have negative sine x to the power 3 minus 4. Now don't forget that you're supposed to multiply by the derivative of what is in the brackets. Derivative of what is in the brackets is 3x squared. The constant minus 4 just disappear. So what you end up with will be negative 3x squared and then sine x to the power 3 minus 4. So that is your derivative there. Alright, so we'll do a second from last question, where y is equal to the natural log of ex squared. Let me write that properly. So we've already looked at the question that relates to this, so pause the video and try this one out. So e to the power x squared over e, that's not e, that's x squared. Okay. So I've already shown you the ways to go about it by expanding the logs, but let me show you the other alternative way now of going about it. So what you'd want to do is First of all, determine the u prime of whatever is in the brackets. What we have in this case, we have e to the power x squared and then over x squared. So we are supposed to apply the quotient rule here. So the quotient rule, remember, your formula is, if you're going to have u over v, our formula is going to be v u prime minus u v prime, right, over v squared. So our v is what's on the bottom. So we have x squared. Now u prime, which is the derivative of whatever is on top, you say it multiplied by the derivative of the power. Derivative of x squared is 2x. So I have 2x attached to the exponential. The exponential, the power doesn't change. And then minus u. U is e to the power x squared. And then v prime. V prime, the derivative of x squared is 2x. Divided by v squared, which is x to the power 4. Right. Okay. So that's where we are at this point. Can we simplify it beyond that point? So if you multiply this and that, you're going to have, that's going to be 2x to the power 3 e to the power x squared as it is minus 2x e to the power x squared as it is over x to the power 4. Now don't forget that at that point you're supposed to divide by the original as it is in the brackets. So that is e to the power x squared over x squared. Now I've already shown you that dividing by something is as good as multiplying by the reciprocal, right? So if we're saying we're dividing by e to the power x squared over x squared, it's as good as multiplying by the reciprocal, meaning that you change, you swap them. So it's the same as we're multiplying by x squared over e to the power x squared. Okay, so let's move to the next step. So if you do that, if you do just that, let's see what you're going to have. So take this to be individual terms, this and that to be individual terms. Okay, so x squared times whatever is on top, we're going to have 2x to the power, that will be to the power 5 now, that will be x to the power 3, and then over x to the power 4 will be attached by ex squared. So you notice that ex squared is now common everywhere, right? It's attached at every point. So you can actually factorize it on top. So if you do pull it out, e to the power x squared, it is going to divide with 1 on the bottom. So what remains as your solution is 2x to the power 5 minus 2x to the power 3 over x to the power 4. Of course you can go on and simplify that. You know that since you've got x to the power 5, 3 and 4, the minimum power is 3. So you can pull out x to the power 3 on top, remain with 2x squared minus 2 over x to the power 4, which can be split. So this and that will go. So you end up with 2x squared over x as a simplified solution. Okay. Now for the last one, we apply the chain rule. Okay. So when you see y is equal to cosine squared and then x to the power 3 minus 4, the meaning there is it's like what you have is cosine and then x to the power 3 minus 4 and then all this is raised to the power 2. That's what it means. Okay, so cosine squared of x is not equal to cosine x squared. These are two different things. Okay, this means cosine of x raised to the power 2. That's what it means. With that understanding, we'll let our u be equal to whatever is in the bracket, so that we have y is equal to u to the power 2. Now we know that our u is equal to cosine x to the power 3 minus 4. So we can basically determine du there. So our du dx, what's the derivative of cosine? Negative sine. So multiply by the derivative, what is in the brackets, that's going to be 3x squared. Okay, if you simplify that, you're going to have negative 3x squared sine x to the power 3 minus 4. Differentiate this in respect to u. It's going to be called dy du, which would be 2u. Now for us to get du dx, dy dx, it's a product of dy du multiplied by du dx. So dy du is 2u, and then our du dx is this part. So negative 3x squared sine x to the power 3 minus 4. Now our u is basically whatever was in the brackets, right? So we said cosine of, so that would be 2 cosine x to the power 3 minus 4. Now we are multiplying by negative 3. Negative 3x squared sine x to the power 3 minus 4. So this times that, we're going to get negative 6x squared, and then sine x to the power 3 minus 4 cosine x to the power 3 minus 4. So what is basically our derivative by applying the chain rule there? If you think you can simplify it to further than this, please feel free to go on. Right.
Alright, so if you're looking to full solutions to the tutorials that you have, basically the calculus one, for example, you see that all the questions have been answered and are available on our site, all the way up to question 11. And of course, the same applies to the other part, the other tutorial sheet, which is on complex numbers. You notice that they are also solved here. You can see the questions all the way up to question 9. So you can actually access all these by just registering on our site. So in addition to that, you can also learn all the other topics that you need to prepare for in your assessments. Okay, so you need to learn limits, videos are here, differential calculus, and also the complex numbers. So all you just have to do is just go to learn.transcendedinstitute.net, and of course every information is in the description on how to go about the registration process. So the same applies to the other courses, chemistry, physics and biology. The theory solutions are available on our site at a very affordable fee of only 80 kwacha per course. All the best as you write assessments.